Walang nagre-record. So ako na lang. Okay, so yan. So let's proceed here. Okay, so combo number 1. So front view, punta tayo sa view here. Front view. Ito yung front view. I see. Okay, so thank you, Tupses. No? Nakano din pala sa FB group. Then, select natin yung ground floor because yan yung i-repeat natin, di ba? I-repeat natin. Select natin. Then, isometric to verify, di ba? Ito yung isometric view. Yung may shade lahat ng faces. That means isometric view. Okay, and then, yan. So, selected. And then, next sa combo 1 ay isolate, di ba? Isolate to the view selected object. But we will just use translational repeat. Wala naman tayong edit na gagawin, no? Magka-copy paste lang naman tayo. So balik tayo sa translational repeat. Okay? Translational repeat. So stop na ako diyan, no? Then translational repeat. And this time it's going Y. No? Going Y direction tayo, and then from our floor to floor height na 3 meters. So that's 2, 3. Okay? 369. Okay? Yan. And then link steps. Okay? Kasi para makapag-create siya ng column, no? Column sa bawat na yan, no? While nagta-translational repeat siya. Okay, and then click OK. Sige, I'll give you 5 seconds. Okay, and then click OK. Yan. So this is now in 3D. Yan, 3D na po siya. Now if you wanted to visualize yung model, right-click, 3D rendering. Yan. However, wala pa siyang extrusion kasi wala pa tayong property na nilalagay. No? So ganyan pa lang siya. Okay. So to rotate this, no, click hold, tapos medyo galawin niyo na lang yung mouse, no, ikot-ikot niyo siya. Anyway, we will do the same again later. So what's next? Next is we can now assign property. Okay, punta tayo sa properties. Okay. And then, assume tayo ng column na 500 by 500. And ano yung in-assume kung ano? Girder. I think 250 by 400. No? Mabagal. Anyway, sige. Palitan na lang natin later kung sakali nga. Yan. So 500 by 500 and 250 by 400. So click define. So nag-click ako ng properties, no, para lumabas itong properties interface. And then of course concrete tayo. So click rectangle. And first yung column 0.5 by 0.5. Okay, and then add. Okay, add. And then for the girder, ZD natin is 0.25 ko na lang to, and then this is 0.4. Okay. So I'll be discussing yung local axis na. Okay, so take note, yung ZD is here, then YD is this. Remember, meron tayong global axis, X, Z, Y. So inside the space, meron kang beam. No? Inside the space, no? May column, may beam ka, your structure. So may global axis dito, then we also have local axis. Lahat ng software yan. No? So if you are planning to be structural engineer, no, as a career, no, you will deal with this terminology. Lahat ng software will have global axis and local axis. Because in theory, that's how you that's how you analyze structure, no? Sa matrix analysis subject namin, to be able to derive a stiffness matrix of a beam or a frame, kailangan mong i-transform yung local stiffness matrix into global stiffness matrix. Parang ganyan din sa software, STAAD. So ganun, no? So locally, ito naman yung convention ni STAAD. So this is your Z, this is your Y. Okay? So perpendicular to that is your X. So ganun din, no? May X, Y, Z din siya. But however, ito ay local axis. No? Local to the member. Pansinin nyo, no? Yung Z is parallel to the width. Okay? Kaya ito ay ZD. Yan. Then yung Y is parallel to the depth. Kaya this is YD. Okay? Now, this is consistent ngayon sa forces. Therefore, if you have a moment on this axis, we call this moment about Z. Diba? About this axis no? So, moment about Z. And if you have force parallel to this y-axis, that is F force or Fy. Yan. And then if you have force parallel to this longitudinal x-axis, that is Fx. Okay? So basically, yan yung tatlong tatlong most important forces sa line element. Now, Mz is what we know as the bending moment. Yan. Yan yung moment na kinukuha nyo sa exam nyo sa TOS, no? Exam nyo sa sa Extrema, di ba? Bending moment. That is Mz. Okay? And then Fy is the shear force. So if you are designing stirrups sa concrete, no, you will get Fy from STAAD. Okay? Then itong Fx is the axial force. That's the axial force. Okay? Anyway, may sa PDF in-explain yan, no? May drawing ako niyan. So click add, then close. So ito po yan sa PDF. This one. Oops. Okay? So tinayo ko siya, no? Tinayo ko siya. Yan, because this is now a column. No, sa column, subjected ka sa biaxial bending. No, hindi ka naman sa isang axis lang may bending because earthquake happens on both x direction and z direction. So may possibility may moment ka on two directions. So yon, sa column, so aside from Mz sa bending, sa beam, you will also need My. Okay? And Fx, of course, the axial. Okay? So may shear ka din sa column, no? Yung Fy and Fz. Okay? I just sent the PDF sa chat, no? Sa group chat. Yeah, okay, FB group. Yan. So yun po. So we will now apply this sa ating ating model. Okay. So this time I'll be discussing combo number 2. Yan. Kung may combo 1, may combo 2. Dalawa lang naman yung combo. click this. Si ano. So basically, ano yun? Select the command, then select the object or the geometry, and then assign. Yun lang. No? Ganun kabilis. Yun. Select the command first. So command muna, no? Bago mo i-select yung object or geometry. Then saka mo i-assign. So, yun yung combo 2. Okay? So select ko muna yung command, which is ito. Kasi ito yung i-apply natin, di ba? Then select ko ngayon lahat ng columns. Then assign. Click assign. Okay? But there is a quicker way to select all the columns using select parallel to Y. Yan. Yan. So select parallel to Y. Remember, because column is parallel to the Y axis, di ba? So select parallel to Y. While the beams are parallel kay X and Z axis. Okay? Sige. So selected yung command, combo number 2, no? Selected yung command, then select punta ako sa beam, ano here, ito beam, then parallel to Y. Okay, parallel to Y. Ayan. So combo number 2, selected na yung command, selected na yung object or geometry, and then click assign. Okay, so yes. So same procedure, select ko yung command, yung 250 by 400, then parallel to X, and then parallel to Z, and then assign. Okay, then yes. Okay, sige, I'll give you 10 seconds to do that. Okay, next is applying supports. Yan, kasi may ano na tayo, may 3D na tayo. Sige, let's check yung 3D nito. Right click, 3D rendering ulit. So yan, so buo na siya. No? Buo na yung ating building. Okay. Okay, so I would advise no, i-model niyo din yung slab, no? So para ma-simulate niyo yung diaphragm ano or yung stiffness niya, no? Pero kasi baka magtagal, no? Kaya hindi ko na lang siya i-model dito. Okay. Then punta ngayon tayo sa supports. Click supports. Okay, and then create. So ang default niya ay fix. Okay? Fix yung default. So ibig sabihin may restraint ka, no? Kumbaga, wala kang movement sa 6 degrees of freedom, no? Wala kang movement sa translational X, translational Y, translational Z, and rotation sa X, rotation sa Y, rotation sa Z. Okay? So click add. Yan. And then apply this. Okay? So i-ano natin, combine natin yung combo 1 and 2. So combo 1, view, front view. Yan. And then combo 2, select the command, then select the object or geometry. Yan. Yung base lang naman yun, no? Then assign. If you wanted to check, pwede kang mag-isometric view to verify. Pero it's very unlikely na masyadong tataasan mo yung ano no yung selection no kasi alam mo naman na sa base lang yung supports no so ganyan lang yung ano mo selection. Okay, and then assign. Okay, so may supports na tayo. Okay, sige, I'll give you 5 seconds. Okay, so after that, open ko lang yung manual namin sa ano kasi andito na yung mga definition eh. Where is the rigid? We'll apply the rigid diaphragm. Where's the rigid diaphragm? Yeah, ito. Okay, so we will apply rigid diaphragms. So this command is used to create rigid floor diaphragms without the need to specify a master joint. Okay. It calculates the center of mass for each rigid diaphragm and creates internally an analytical node at the center of mass. Okay. So why is rigid diaphragm important? No? Okay, may question. Is it okay to use pin? Pag mga ano po, no? Pag mga two-story lang, no? Pag mga two-story na magagaan lang, no? You can use pin, no? Ayan po. Pwede po, no? Provided na walang instability, no? Because minsan, syempre, although magaan lang siya, pero let's say marami ka namang irregularities such that may possibility na magkaroon ka ng instability, mapipilitan ka mag-fix, no? Pero of course, when you go higher, no, as your model increases in height and in mass, no, wherein malaki na yung lateral force mo, yan, mag-fix ka talaga. Okay, so ito po. Rigid floor diaphragm. So, it calculates center of mass. Mahalaga kasi yung center of mass because where's my So ito nasa ano to no discussion ng earthquake engineering. If this is your plan wise, no, if this is your building, where's my yeah. Yan. So say ito yung center of mass mo. From the word itself, di ba, center of mass, no? Parang dyan concentrated yung mass. If you apply say Varignon's theorem, so sa gitna, no? Of course, kung symmetrical yung distribution ng masses mo, most likely nasa gitna. Okay? We need center of mass because we will compare this with the center of rigidity na tinatawag. Yan. So center of mass is yung distribution ng masses, no? Kung nasa ano siya, kung ano yung centroid niya. While the center of rigidity is the distribution ng stiffness. Okay, halimbawa si architect, gusto niya andito yung poste mo. Yan. Tapos say high rise to or mid rise no pinag-usapan. Tapos ayaw niya ng shear wall sa right side dito. No? Pinagbigyan ka lang niya dito sa left side, no? Engineer, dito ka na lang mag-shear wall. Yan. Okay? Anong tendency ng rigidity mo? Yung rigidity mo will lean towards to the left. No? So sabihin na natin nandito na siya. No? Yan. So pag yung difference, yung distance between the center of rigidity and the center of mass is what we call the eccentricity. Okay? And that eccentricity, plan-wise, will induce torsion. And that will induce torsion. Kaya mahalagang makuha yung location ng center of mass and the location of center of rigidity. Because the difference between them will be your eccentricity and that will cause torsion. And lalo na kung mid-rise na or high-rise, obligado ka na mag-dynamic analysis. So sa dynamic analysis, dapat ang first mode mo will not be torsion or rotation. It should be translation. No? Kumbaga mortal sin, no? Mortal sin na rotation ang first mode mo. Remember, first mode is, di ba, kung ito yung building natin, we idealize as a stick model, basically parang ganyan lang siya, di ba? During earthquake, no? We're talking about earthquake, dynamic analysis nga, no? It may move left to right, parang ganon, no? Pero when you perform dynamic analysis, at least yan dapat ang first mode. It should not rotate na something like this. Okay, as first mode. Okay, ibig sabihin, pag yan ang nag-govern, sobrang irregular ng structure mo. Yeah. Yan, yeah. Advisable din naman maghihiwalay ang superstructure sa substructure. I mean, it depends na rin sa iyo kasi, no? Depende na rin sa pinag-uusapang laki ng structure, no? Kung maliliit lang naman, no, kahit magkasama na, no? Kasi yung concept kasi ng substructuring, syempre ginagawa talaga yan kapag lalo na sa finite element analysis, may substructure ng wing, halimbawa ng eroplano, may mag-a-analyze ng wing, may mag-a-analyze ng yung ulo, may mag-a-analyze ng ano. Ganon dati ang ang idea ng substructuring. Kasi nga walang no, on the old days na walang malaking specs ng computer, they cannot analyze structure or na kasi nga wala silang hindi kaya ng machine, no, hindi kayang mag-analyze ng large size of matrix. Remember, all we are doing is in matrix, no? Naka-matrix yung stiffness natin. Kaya nakakapag-analyze tayo in 3D because kaya ng laptop, kaya ng PC. Kaya nagkaroon ng concept ng substructuring. Ayun po. So first mode translation yan. So not torsion. Anyway, we have a way to to initially guess kung torsion na mag-govern, no, mamaya, no, sa output, sa stiffness, sa lateral stiffness. Okay. Yan. So mortal sin na wag mag-torsion as first mode. But no, inaalaw ni code na magkaroon ka ng accidental torsion na tinatawag. In fact, sabi nga ni code, kahit pa regular yung structure mo, sabi niya, maglagay ka pa rin ng accidental torsion. No? Parang at least hindi mo naman masasabi na talagang ang center of mass mo is always nandun sa location na yon. Parang siyempre in actual baka may eccentricity ka kahit paano. Okay, so code is allowing for accidental torsion 0.05. Yan, diniscuss ko din yan sa channel ko yung concept ng accidental torsion, even yung specific provision sa code. Ayun po, so yun, rigid diaphragm and bakit nga tayo may rigid diaphragm then is that is because of the rigid diaphragm, we can say that the displacement of say ito na nga lang. So kung ito yung frame mo, elevation, yan. So kung nagdi-displace yan during earthquake, di-displace ng ganyan yan. Siyempre cyclic yan, no? Left to right, no? Because of the rigid diaphragm, let's say this is delta 1, the lateral displacement dito sa node na to, this is also delta 1. Okay? And say this is delta 2, this is also delta 2. Okay? And the rigid diaphragm is caused by the in-plane stiffness ng slab. Yan. Mataas yung in-plane stiffness ng slab. No? Yan. So you say ito yung earthquake mo. No? Mataas yan. No? When we say in-plane, no, it's the deformation in this plane. No? Okay. While out of plane is the bending. Okay. Yan. Because wala ka na sa plane na to. Sa axis ng plane na yan, ng slab. So that's the out of plane bending. Now, in earthquake, hindi naman siya magbe-bend ng ganyan, no? Because ito ang mag-activate yung in-plane stiffness na yan. Okay? Therefore, it's an engineering judgment, no? Ang diaphragm, no? Na check mo yung structure mo. Kung roof deck ka sa taas, so you can assign a rigid diaphragm there. No? Kung hindi naman, let's say truss ka lang dito, huwag mong lalagyan ng rigid diaphragm command. Okay? So that's why, yun nga, sinasabi ko din na pwede niyo i-model yung slab, no? Kasi kung say truss dito sa roof level, so syempre walang slab yan, no? Unlike kapag minodel mo yung slab, you are actually no, incorporating the stiffness of the slab na. Okay? Okay, so proceed with the diaphragm command. Punta tayo sa specifications and then node. Specifications, no, and then node. Yan, no. So previously kasi master slave lang yung available, hindi po yung floor diaphragm. Yung nung STAAD V8i pa, no, early releases. So ito yung ginagamit ko. Master slave, no, before. From the word master and then slave. Sabihin, mag-a-assign ka ng master, tapos gagawin mong slave yung mga other nodes. So ibig sabihin, kung ano nangyayari kay master, yun din mo pangyayari kay slave. Okay? Kung sinet mo si master na may rigid siyang deformation, magiging rigid deformation din yung mga slave. Kung sinet mo lang siya na rigid sa XZ plane, kumbaga, kung ano yung displacement niya dito, say 10 mm, ang magiging displacement din ng mga slave is 10 mm. So, if you're using master slave, advisable ang XA. No? XA po. Wag rigid, no? Not rigid. Wag niyong don't interchange the rigid term here ng software versus the rigid diaphragm term ng textbook. No? Magkaiba po, no? Magkaiba 'yon, no? This is software, ano. Kasi pag sinabi niyang rigid dito sa software, lahat ng degrees of freedom, no? So such that wala nang wala ka nang tawag mo doon, parang in all directions, no? Rigid siya. Hindi naman, no? Because yun nga, magdi-displace ka laterally. Okay? So we're using floor diaphragm. Yan. So typing job lang to. So ta-type mo lang yung yung mga elevations nito. 1 2 3 4. So this is 1.5. Okay, 1.5 muna. Add. Then node ulit. 1.5 plus 3, 4.5. Add ulit. 4.5 plus 3, 7.5. Add. 7.5 plus 3, 10.5. Okay? Yan, kasi roof deck tayo. No? Kaya nilagyan ko din siya ng rigid diaphragm. Okay, what else? Next is section crack, no? Property reduction factor. Ito naman. Yan, section crack factors. So ito yung table ni ACI, ito naman yung table ng NSCP po, no? So ano sabi niya dito? This is the moment of inertia and cross-sectional area permitted for elastic analysis at factored load level. So sa columns daw, we'll use 0.7, sa beam 0.35. So syempre, inadapt ni NSCP because we are an American colony, no? So gagamitin natin American code. 0.7, 0.35. Kaya yung ACI is an American code, ASCE, lahat dyan, AISC, yan. So US code po yung mga yan. Kaya nga tip ko sa mga sa mga career sa mag-structural, no? Kung may mga vague na provision sa code na hindi niyo mag-gets, mag-refer kayo sa American code. Kasi ang maganda sa American code like ACI, may commentary. No, when you read it, sa right side, nandun yung explanation ng code. Yun po yung yung advantage. Siyempre si NSCP kasi kinumbine yung mga referencing other international code Siyempre, wala nang ano, kakapal na masyado pag sinama pa yung mga commentaries. Okay, so by the way, no, elastic analysis. So take note of that, no. Ang ginagawa natin ngayon is elastic analysis. Okay? However, ano ba yung nakikita nyo sa earthquake? Mga past earthquake disaster, di ba? Meron bang structure na walang crack? Di ba? So in reality, ang behavior ng building natin is inelastic. Okay? Now, syempre, since a nonlinear analysis is very complicated, no, kumbaga hindi siya agad, no, hindi siya agad maka-capture ng typical graduate or engineer na walang advanced study. So, to compensate for that, no, parang sinabi na lang ni code na i-0.7 natin si column, 0.35 si beam. And bakit inelastic? From the formula kanina, no, ng base shear, CVI over RTW, this R value is actually 8.5, no, if you're using SMRF, special moment frame. Okay, this actually reduces the base shear. No, that's why in some textbook, this is called reduced base shear. Okay, ibig sabihin, ni-reduce ni code yung base shear ng building natin. In reality, what we are expecting is much greater than this. Sabi ni code, parang magmamahal kasi ang structure mo kapag i-design mo siya at full earthquake load. Now, which only happens once every 500 years. Statistically. Okay, so para hindi magmahal yung building mo, i-reduce na lang natin siya, basta't make sure na merong kang R na 8.5. That's why it's called as ductility factor. Yan. So make sure your structure is ductile. No? Diba? The term ductility is parang it's the ability to absorb a lot of strain, di ba, beyond the yield. No? Kumbaga, and heads up, no, parang sabihin ko na, no, the ductility of the structure relies heavily sa steel. Ano ba ang stress strain ng steel? Yan, sa mga nag-CMT na dyan, no, ganito ang stress strain ng steel, di ba? This is the stress, this is the strain plot. And itong portion na to, ito yung yield. Diba? Ito yung yield strength, or so we say Fy. And ito, mahaba yan, di ba? So beyond the yield point, the steel can absorb, no, a lot of energy, a lot of strain. No? So parang ganyan din, analogous din sa structure natin. No? Because the structure's ductility relies heavily on steel, lalo na sa confinement. No? Parang ganyan din. No? We can make sure, no, parang sa sinabi ni code na ibababa ko yung base shear mo, pero make sure your structure is ductile. No? It can absorb a lot of deformation beyond its yield. Okay. So yun po. So apply that. Punta tayo sa beam property reduction factors. And then 0.7. Yan. So dalawa to, no? 0.7 at then ulitin natin beam property reduction. So 0.35, no, sa beam. Yan, then add. Okay, then add. Yan. Okay, so apply natin, no? Combo number 2. So select the command, then select the object, di ba? Yung 0.7 for the column. Okay, select parallel to Y. Lahat ng column, no? And then, selected yung command, selected yung object, and then assign. Okay, for the beam, select the command. Okay, select the object, parallel to X, parallel to Z. Oops, wait lang. Humaharang tong ano. I-disable ko yung waiting room para hindi ako mag-a-admit isa-isa. Okay. Yan. Parallel to X, parallel to Z. Isometric view ko. Okay, so assign. So save natin, no? Baka mag-crash. So from time to time, mag-save po kayo. Okay? Yan. So after that, we can now create tayo ng group. No? Kasi di ba isolate natin yung for live load 2 and then live load 1. Okay. So very powerful ang group, no? Ang ginagawa ko, i-group ko yung mga exterior girder at saka interior girder. So ganun din sa columns. I-group ko yung exterior column, corner column, interior column. Kasi as an engineer, 'di ba? We are aiming for symmetry. 'Di ba? Because earthquake can come in both direction. So dapat yung strength mo on this side should be equal at least sa other side. Pag nandito yung earthquake, yung strength mo dito equal din dapat dito. So kung ano yung size ng girder mo diyan, column mo diyan, as much as possible, yun din yung size mo sa other direction. Okay? Kaya when you group, no, you are basically sorting out forces na common sa kanila. Tapos para ang design mo common din sa kanila. Isang label din, isang type. Okay, so to access group, ang shortcut ay Control G. Control G. Create group. Control G. Yan. Tapos, mag-create ng dialog box, no? So, unahin natin si LL1. Yan. For live load 1. Siyempre, ang load type is floor. Floor siya, no? Kasi, i-group natin yung loading niya. Okay? So, typing job muna to. Then, ganun din. Kikreate ako ng for LL2. That means yan yung 4.8 kilopascal. Then, floor. Okay. Sige, pakita ko na rin for the girder, no? So, halimbawa, EXT girder. Exterior girder, no? Wala kasing no? Hindi ka pwedeng mag-name ng group na may space. So, kailangan underscore, no? Kung if you wanted na may space between the name, no? So, EXTG ko na lang, no? That means exterior girder. So, ang type niya ay beam, no? Say beam siya. Okay. What else? Sample din tayo ng column, no? Create, say, exterior column. EXT call. Yan. Of course, beam ni ulit yun. And then, okay. Ganun na rin sa footing, no? Gawin na rin natin sa footing. Sabihin natin corner footing. CORFTG. And dahil footing yan, node yon. Yung foundation level kasi nasa node eh. It's a node type, no? Node object. So node siya. Yan. Okay. Yan. Sige, I'll give you 10 seconds to type that. Okay? And then, assign tayo, no? Mag-assign na tayo dyan. So, unahin natin si LL1. Okay, so, combo number 1. Front view. Yan. Ise-select ko lang si second and third. Second and third. Okay, then isometric to verify, no? Anong susunod sa combo 1? Isolate or view selected objects. Yan. And then, commonly sa top view ka mag-edit. So, top view. Yan. Okay. So, ang LL1, yun yung non-corridor live load. Ito po yun. Yan. Select ko yan. Parang AutoCAD lang. Press Control for multiple selection. No? For multiple selection. Yan na lang. No? I-set na lang natin ng ganyan. Okay. Oops. Select ko muna yung LL1. Okay. Isometric to verify kung tama. Okay. Tama naman. Okay. So, ito yung floor group for LL1. Kasi nandito yung hagdan eh. No? Then, selected yung command. Selected yung object or geometry. And then assign or associate. Okay. Bakit hindi associate? Okay. That's it. Okay. Associated na siya. No? Next is LL2. LL2. Click ko yung LL2. Then select ko to. So ito yun. Pa-L siya. No? Kung from the gym, yan. Kumpulan yung tao, maghihagdan, no? Going down. Okay, so selected yung command, selected yung object or geometry, and then assign or associate. Okay, so pansinin nyo, naka-ano na siya. Floor assigned na siya. Okay. Yan. Tapos, if you wanted to return back to the original view, display whole structure. Yan, display whole structure. Yan, sige, so i-demo ko naman yung mga exterior girder. Halimbawa, sige, select. So, select ko muna yung mga beams, no? X, parallel to Z, and then isolate, no? View, selected view selected objects. Then top view. Yan. So, i-group ko yung exterior girder. Halimbawa, select ko yan. Select ko to. Select ko yan. Yan. Actually, kung exterior girder lang pala, no? I-out natin to. Itong tie beam. Wala naman pala tayong tie beam. Anyway, itong nasa ground, no? I-out ko yan. Substructure level na yan, no? Yan, ako muna to. Select ko muna to. Then isolate ko siya, no? View selected objects. Top view. Yan. So, selected yung command. Selected yung exterior girder. Yan. Yan. Okay, and then associate. How about the exterior column? So display whole structure. Tapos top view. Yan. So I'll be selecting from left to right. No? Ito yung mga exterior column. And okay. Left to right. I'm pressing control, no? While selecting. Parang AutoCAD, no? For multiple selection. Yan. Isometric to verify. Yan. Okay. So selected yung command. Selected yung mga objects. And then assign or associate. Okay. Okay, then last is corner footing. So here, kailangan, mas maganda, ang selected lang yung base. No? So, combo 1, front view. And then, dahil node ang isa-select ko, right-click, select cursor nodes. Okay? And then, select ko yung base. Yan. Isometric to verify. Okay? And then, isolate. View selected objects. And then, top view. So, corner footing lang. So, yung corner lang. Select ko yan. Select ko to. Ayan. Like this. And then, isometric to verify. Medyo hindi nyo lang nakikita, no? So, to disable yung support, ang kiklik nyo ay Shift, stop, Shift S, na natabunan lang, no? Nahiwalay. Shift S. Shift S. Okay. So, kung gusto nyo matandaan yon, no? Or mabalikan, right-click lang kayo, punta kayo sa structure diagrams. Sabi ko nga, di ba, earlier, no? Na madalas sa right-click, nasa right-click ang answer. Structure diagrams, punta kayo sa labels. Yan. So, may mga letters beside the command. Yan. Shift N, sabihin, in combination with the Shift button plus the letter na mga yan, ma-activate nyo yung command. So, Shift N, mapapalabas mo yung node numbers. Shift K, yung mga node points. Shift S, mapapalabas mo yung supports or madi-disable. Shift B, beam numbers. Okay? So, nasa right click lang, no? Okay, so alisin ko si support. Ayan. So, yun yung mga corner footing. So, selected yung command, selected yung object or geometry, and then assign or associate. Okay? Yan, may group na tayo. Okay, next is reference load. Yan, display whole structure muna ako. Then, punta na tayo sa loadings. So, napapansin nyo, no? Even from old STAAD version, hindi nila tinatanggal to. Because this is correct. No? Ito yung flow eh. No? Magjo-geometry ka muna, magmo-model ka, maglalagay ka ng properties, assign ka ng materials, kung mayroon kang different materials, may strength, may density, yan, tsaka mag-assign. Specification, that's what we did sa diaphragm command, and yun, magre-release ka ng mga members, dyan din, supports, and nandito na tayo ngayon sa loading. No? So, ang bilis lang, no? After the loading, analysis na. Okay. So, loading, and then reference load. Okay, siguro, so wala yung reference load because nandito po siya sa definition. No, i-expand nyo to. Expand natin yan. And then click reference load. Okay, and then add. Okay. So, very important sa reference load kasi, no? Siguro yung mga doon sa yung follower ko dun sa channel ko sa C reference, no? Hindi ako nag-reference load, no? Kasi hindi ito yung nauna kong natutunan, no? Nalaman ko lang din to in practice na sa industry kasi yung original na tutorial doon is 5 years or 6 years ago yata, no? So yan, ang alam ko yung kumbaga yung manual method of assigning weights and dead load, ganyan, no? Sa reference load, ang maganda sa kanya is pag nag-assign ka dito, nag-set ka ng mga reference load, say dead load, magagamit mo siya agad dito sa seismic definition. Yan. Kaya mapapansin nyo, nauuna si reference load bago si seismic definition. Now remember, ano nga yung formula ng earthquake? CVI over RTW. You need the weight. No? You need the weight first, no? Para makompute niya yung base shear. That's why nandito siya sa reference load. Okay? Then, sa load case details dito, nandito yung mga primary load natin, the EX, the EZ, and DL1, dead load, live load 1, which is possible na i-reference mo siya dito. So whatever happens sa reference load, you do not need to change here. No? So parang andito si master, no? Nandiyan yung master load mo sa reference load. Ganun siya kaganda. Okay? So, let's say, nagbago yung model mo, no? May tinanggal kang column, may nilagay kang wall. So, baguhin mo lang si reference load. Because from this concept, whatever changes sa weight mo should be updated sa model. Kasi dependent nga yung base shear mo. So, therefore, kung varying yung weight mo from time to time, say, di ba, si client, madalas yan, may papa-approve si architect, magbabago na mahalan. No? So there's a tendency na magbago yung weight mo from the conception ng project all the way hanggang construction. So sa reference load, no, mabilis. Okay, so typing job lang naman muna tayo. So ang i-reference load ko lang ay si DL1, that's a self-weight. Okay. And of course, yung loading type niya ay dead. Importante to, no? You should assign this as dead load para ma-read ni STAAD as mass. No? That's the self-weight. So add. Then DL2, ito yung superimposed dead load natin. Again, dead load ulit siya. Then add. Okay, and then close. No, hindi siya included. No? Yun nga, because as I explained earlier, no, wind load will not govern. Okay, so ayan, so lagyan na natin ng laman yung dead load 1 and dead load 2. Siguro let's finish on this reference load, then we'll take a break at 11 a.m. So ito yung where's the PDF? Ito yung mga assumed loading ko. Yan. So DL1, assume ako ng weight ng slab as 125 mm thick. Ref 125 mm thick. So assume tayo ng unit weight ng concrete na 25 kilonewton per cubic. So 25 times 0.125 is 3.125 kPa. Okay? For the DL2, yan naman yung superimposed dead load. Because may hinihiwalay siya because may tendency mabago nga din to, no? Ang superimposed dead load. Unlike yung self-weight, madalas kasado na yan, established na yan. Pero itong superimposed, pwede mabago din yan. So floor finish, assume tayo ng 1.10, ceiling 0.15, MEP, kasi of course may mga ka dyan, lighting, mga HVAC, yan, may mga linya ka ng dyan, aircon. Interior partition, assume na lang tayo, no? Maglagay tayo ng 1 kPa. Assume na by possibility maging office, office setup, no? Open ko si NSCP 2010 for the loading. Dead load. Yan. Andito si partition load. No? Sabi niya, floors in office buildings where partition locations are subject to change shall be designed to support in addition to all other loads, dead load equal to 1 kPa. Makahiwalay siya, no? Yan. So, halimbawa, yung mga drywall, magbago yung location nun, no? So, that's 1 kPa. For the, saan yung tabulation ng ano? Ito po. Ito yung 1.10 sa finish. Yan, ceramic tiles, 20 mm on 25 mortar bed, 1.10. Okay. So, MEP, although hindi exactly 0.10 yung nandito, dito kasi 0.2 eh. No, yung nilagay ko sa manual is 0.10 lang. No? Pero still nasa range naman siya. No? Ceiling, 0.15. Ito, yung mga ceiling dito ay yan, 0.10. Nasa range naman. No? Okay. Wood fairing, 0.12 naman. Okay. For the CHB, so nag-assume ako ng 2.5 kPa full grout. Yan. 100 mm thick. So ang density niya ay 16.5 kN per cubic. Yan. Full grout is 2.5 kPa. Yan. Sabi ni code, mag-add ka daw ng 0.24 kilopascal each phase. Yan. Kaya ang computation dito ay yan, 2.5 plus 0.24 times 2. So 2.98 kPa. Di, ano yung height natin? 3 meters, di ba? Yung floor to floor. Ilas natin yung beam depth. 0.5 pala na siya dito. No? Anyway, yan. So 2.5 multiply natin sa 2.98. So that's 7.45. So yan yung DL2 natin. Okay, sige. So gawin natin. Unahin natin yung DL1. So the self-weight. So click natin si DL1, then add. Okay, self-weight load. Default naman siya, nalalabas. Kasi nga, load type natin ay dead load, then add. Ayan. And then yung floor load, kasi in KPA tayo eh, no? Is, ano nga yung ano natin? Slab, 3.125. Negative 3.125. Ayan po, yan, 3.125. Okay, then click. Okay, 3.125. Yan. So, saan ba natin i-apply si slab? So, meron tayong slab from second floor, third, hanggang roof, no? Kasi roof deck yan, no? Yan, no? Yan. So, hindi natin ko-consider yung slab dito sa ground. Remember, ano bang typical detail ng slab on ground? Di ba? Parang ganyan. Ito yung column mo, ito yung slab on grade mo. Yan. Tapos may separation dyan, no? Or sa construction ng typical detail, PEJ, no? Yung nilalagay nila. So, technically, hindi attached si slab on ground kay column. Hindi siya monolithic. Unlike si second floor, yan, attached siya. And even third floor hanggang roof deck. So therefore, yung weight ng ating second floor slab will transfer ultimately kay foundation, which will ultimately contribute sa ating base shear, right? The weight. Unlike itong slab on grade, hindi. It's resting directly sa soil. So hindi natin siya isasama. Okay? So therefore, ang imo-model nating slab is from second, third to fourth. And may shortcut dito eh, no? So global Y, ano yung minimum Y natin? Minimum Y. So remember, ano yung coordinates nito? This is 1.5, this is 4.5, no? 4.5, tapos this is 4.5 plus 3, 7.5, plus 3, 10.5. Yan. Tapos isi-set ko yung minimum ko na Y para ma-cover ni STAAD, ma-detect niya. Say kahit 4 meters. No? Set natin na 4. Tapos set ko na maximum ay say 11. No? 4, 11. Ibig sabihin, i-detect ni STAAD lahat ng may occurrence ng slab from 4 meters to 11. Kumbaga, kung may geometry ka sa 4, lalagyan niya yan. No? So wala siya na-detect, so 4.5 siya na-detect, lalagyan niya ng slab load. So 4 to 11. Yun lang yung pinak-shortcut niyan, no? 4, 11. Okay, then add. Pansinin nyo, maglalagay siya. Ayan. Ito na po siya. Okay? Then close. Tingnan nyo, pag clinic natin yan, automatic na. Okay? Okay, next is self-weight. Yun nga, self-weight. So, combo number 2, di ba? Selected yung command, then select natin yung buong structure. Yan. Okay, so selected yung command, selected yung structure or object, and assign, di ba? Yan. Kaya, be conscious sa word assign. No, by default kasi dito, hindi nakaklik yung assign to selected. No, so, click muna natin to. Yan, and then assign. Okay, yes. Okay, that's it. We're done sa DL1. Okay po. So before we take a break, so tapusin natin tong DL2. Yan, which is the 2.35. Sa roof pala, 1.25. Tinanggal ko yung interior partition. Okay. Okay, so DL2, add. $2.35. Okay, floor load, negative 2.35. And then, so, iba yung nasa roof, no? So, ang kailangan ko lang coordinate is from here to here. So, that is a 4 to 4.5 plus 3, 7.5. 4 to 8 na lang. So, gawin ko 4 to 8. So, minimum Y is 4, maximum is 8. Okay, then add. And click add. So, nandito na po siya. Okay, how about 1.25, no, sa roof? Negative 1.25. Bawas na siya, no, kasi wala naman na tayong mga partition dyan eh. Okay, so that is 10.5 elevation. So, sabihin natin 10 to 11. 10 to 11. Okay? Kasi nasa gitna siya. This is 10 meters and 11. So, yung i-cover niya yan. Okay? Then, add. Close. Yan. So, iwalay na, no? So, mapapansin nyo, pag clinic ko to, siya yung magbo-blue. Okay? If I click this, ito naman yung magbo-blue, yung taas. Okay? And last is the wall, no? The CHB exterior wall. What's that? It's 7.45. Okay, so DL2, by the way, saan natin siya i-click? At lagay ko na lang siya dito. Ito sa tatlo. Okay. So combo 1, view, front view. Select ko itong mga to. Press control. Yan, dyan. And then isometric to verify. Then isolate. View, selected objects. Okay, and then top view. So sa exterior natin siya ilalagay, no? So kumbaga, ito, ano na to, kumbaga, engineers, ano nyo na to, no? Discretion, no? Kumbaga, sa 3D render, no, wala siyang CHB load doon. Siyempre, may tendency na, let's say, si client, no, later on, mag-decide siya na, ano, oops, na lagyan niya ng CHB yan, no? So, it's wise na lagyan nyo na rin, no, ng CHB load. Okay? Okay, so, add, and then, sinelect ko muna yung DL2, no? Member load. Then negative 7.45. Member load na siya. No? Kasi kilonewton per meter. Then add, close. So combo number 2, select yung command, select yung mga exterior beam. Yan. And then isometric to verify. Okay, and then assign. Yes. Okay, that's it. We're done sa reference load. Okay, so it's 11 o'clock. So let's take a 15-minute break po, no? Then let's resume after. Ganyan kasi kami sa ano, sa extractors, every 2 hours, no? Okay. Okay, so sige, so let's resume after 15 minutes. Pala yung file, no? Send ko na yung file, no? Yung latest file.
Ayan. Thank you for that amazing tutorial about the modeling of low-rise building using STAAD Pro Engineer Bersamina.
Grabe pala talaga yung STAAD Pro, partner. No? Parang nare-refresh tayo sa mga subjects na na-take na natin before. Sobrang dami na agad nating natutunan. Sa first part pa lang yan ng ating event, partner.
Yes, nasundan mo naman ba?
Yes, partner. Kailangan masundan natin. And also, sa ating mga TUP students, re-remind ko lang na kailangan masundan nila yung tutorial and yung para may chance silang manalo at the end ng ating event, partner.
Ayan, tama ka dyan. So, now we'll proceed to, this event will not be possible without our sponsors.
X-Structures Engineering Consultants provide fundamental software trainings for architecture, engineering, and construction. Kaya humabol na kayo and enroll now. Bleaves. With Bleaves, you can read the book or use your gadgets while snuggled under the comfort of your blanket with sleeves. Village of Etodes, a Japanese-inspired brand for your low-cost and good quality merchandise and design. Creo PH, your one-stop shop for your personalized gift needs. Book for less. Provide academic books for much lesser price. Guarantees that all books are high quality, brand new and sealed. And our media partners, Ingeniero.org, which their mission is to empower Filipino engineers and to promote technological innovation. They also now have their first merchandise. Avail it now by checking their page. And Engineered Math, a page that helps everyone with their studies in mathematics, science, and engineering subjects.
This event is also brought to you by American Concrete Institute of the Philippines, Polytechnic University of the Philippines Student Chapter. Eulogio Amang Rodriguez Institute of Science and Technology, Civil Engineering Students Organization. FEU Institute of Technology, Association of Civil Engineering Students. Junior Philippine Institute of Civil Engineers, Lungsod ng Maynila. Philippine Institute of Civil Engineers, Philippine College of Science and Technology, Calasiao, Pangasinan. University of Manila Association of Civil Engineering Students, and in cooperation with Association of Civil Engineering Students, Philippine Institute of Civil Engineers, Technological Institute of the Philippines Student Chapter. And lastly is the University of the Philippines Association of Civil Engineering Students.
Yes, and while we're having a break from our tutorial, magkakaroon muna tayo ng palaro. There are 2 winners that will have the chance to win 1 set of X-Structure merch, which includes a mag, lanyard, and mousepad. Ready na kaya yung mga participants natin, partner?
Oo nga, tanungin natin sila. So ready na ba ang ating mga audiences para sa ating unang roleta ng ating prizes today? Wait lang natin yung i-flash sa screen ng ating roleta.
Yes, partner. Grabe, nakaka-excite. Natuto ka na, may chance ka pang manalo, partner.
Ayan, wait lang natin.
Yes.
Brace yourself as we roll our first lucky winner. Boom, tarat, tarat.
Grabe. Mapapasayo ka talaga, partner.
Our first lucky winner is Tamayaw Maria Andrea Nicole N. Ayan. Para sa ating first, pakigalaw po ang baso at magparamdam sa ating FB Live comment section or sa Zoom chat to confirm na nandito ka today sa ating event.
Yes, congratulations sa ating first lucky winner na si Maria Andrea Nicole Tamayaw.
Nandito ba siya?
Andyan ba siya, partner? Mag-comment po or mag-chat dito sa ating Zoom chat para malaman namin kung nandito po kayo. Ayan.
Nandito na ba siya? Na-confirm
Andyan
na
pa siya. Parang hindi pa siya sumasagot, partner.
Tatanong natin ngayon ng ating committee kung magbubunot ba tayo ng name since wala, hindi nag-respond ang ating
Yes.
first.
Yes, hintayin natin. Yes, may mga nagre-request, partner, ng house and lot daw.
Ay, naku,
Yes,
wala
gusto
tayo.
ko rin yan. Gusto ko rin yun, partner. Ayan, salamat Shopee daw, sabi ni Juan Rafael. Yes, salamat Shopee. Malapit na mag-sale, partner. Ayan, mukhang wala siya, partner.
Wala siya. Ayan, pwede pa yan. Plantita package. Possible pa. Pero house and lot, next time na lang.
Yeah. Mas okay ako sa kabuhayan package, partner. Ayan.
Ang first
Wala.
lucky winner, tama ba?
Yes, wala yata yung first lucky winner natin, partner. So, magroleta ulit tayo.
Jeronimo Jordan P, andito ka po ba? Comment
Yes.
po kayo sa FB Live comment section as well as the Zoom chat kung sakaling nasa Zoom po kayo.
Yes, andyan ka ba, Jordan?
Ako mukhang wala din si Jordan.
Kung wala rin si Jordan, partner. Ako, partner, kung gusto ko manalo sa ruleta, ay feeling ko magre-request tayo sa mga prof natin ng auto pass, partner. Gusto mo ba yun?
Sobrang tight din ng reward.
Yes. Lalo na pa-finals na tayo, partner. So, lahat tayo gusto na ng auto pass. Feeling ko lahat din ng participants natin, partner, gusto ng auto pass eh.
Mukha nga, kailangan natin yung lahat.
Siyempre. Wala pa rin yata si Jordan Jeronimo.
Ayan, mukhang magro-ruleta tayo ulit.
Yan, sayang naman yung merch, partner. Di ba pwedeng
Whatever
kapag
po
hindi?
nabunot kayo, please comment po agad sa Zoom
Yes.
o kaya sa FB Live comment.
Yes po. Ayan. Okay, roleta ulit tayo. Okay, para pa rin sa ating first lucky winner, nandito ba si Mir Janina R? Andyan po ba siya? Paggalaw po ng baso.
Comment po kayo sa ating FB Live comment section and Zoom
Sa
chat
Zoom
to
chat.
confirm your ano po.
Okay. Yes, andyan po ba siya? Janina? Hello, andyan ka po ba?
Naku, sayang ang mug at lanyard, no?
Saka mousepad partner, grabe magagamit natin yun. Lalo na ngayon, online class, di ba? Sobrang magagamit natin yun. Andyan po ba siya? Naku, kung ayaw nila manalo, partner. Sa atin na lang kaya to.
Tag-isa tayo.
Oo, ayaw niyo manalo. Asan kayo? Ano, wala po ba?
Iroroleta natin ulit.
Ayan, roleta ulit tayo. Ayan, para pa rin sa ating first winner, sana nandito na si Galiza Nick Angelo V. Andiyan na po ba siya? Nick Angelo V. Galiza. Sana nandyan ka na kasi nanalo ka.
Comment po kayo sa FB Live comment page and sa Zoom chat if ever na nasa Zoom po kayo.
Yes. Andyan po ba siya? Grabe. Sabi nila baka daw sobrang busy sa pag-model ng STAAD party. Grabe kinakarir nila. Kinakarir nila yung STAAD.
Mukhang nag-take sila ng break.
Sumabay sila kay Sir Versa sa pagbe-break. Sayang naman.
Mukhang magbubunot tayo ulit for the end time.
Yes. Sige, roleta ulit tayo, partner. Ayan, nandito kaya si Mangeron, Elton Matthew S. Andito ka po ba? Mangeron, Elton Matthew S. Pa-comment na lang po sa Facebook Live or sa ating Zoom chat kung nandito po si Elton Matthew.
Ako, mukhang wala pa rin.
Grabe. Ayaw nila. Ayaw yata nila. Wala pa rin sila, partner. Ayan, may nag-volunteer na manalo. Pwede ba yun?
Pwede ba yun?
Pwede ba yun? Oh, sige, tatandaan natin yan. Yung mga nagbo-volunteer. Siguro kung recitation to, feeling ko, hindi nila gusto yung mag-volunteer, partner. Mine na lang daw. Pamine-mine na lang po. Wala po ba si Elton Matthew? Wala yata, partner.
Ako, bubunot tayo ulit. At hindi ko na alam kung pang ilang beses to.
Yes. Sayang, ang dami na.
Para pa rin sa ating first lucky winner, Enrique Earl Justin S. Pakigalaw po ang bahay by commenting on the Facebook comment and Zoom chat para po ma-confirm na nandito po kayo.
Yes. Sana nandito ka na, Earl Justin Enrique. Andyan po ba siya? Ayan. Mine po, hollow blocks. Ay, wala po tayong hollow blocks dito. Mine po na, ay, martilyo. Wala pa rin po. Ang may offer lang po namin, mug, lanyard, and mousepad. Wala pa rin po ba si Earl Justin S. Enrique? Grabe, parang ayaw nila.
Names, no? Nakailang ulit na tayo pero ayaw nila. Wala sila dito. Sayang. So, muli, bubunot tayo ulit.
Yes, roleta ulit tayo, partner.
At sana nandito na siya ngayon.
Oo, sana. Sayang naman. Yes, mine roleta. Sige, yours na po.
Sanda lang po ng details. Sanda lang po.
Ayan. Para pa rin sa first winner natin, sana makuha na. Donnie Angie Fuertes. Nandito po ba siya? Ayan, may nag-comment. Andyan daw.
Andyan daw po siya. Pero,
Pakigalaw po yung baso.
kailangan siya po mismo ang mag-comment po. To confirm.
Yes po. Nasa FB Live daw po si Donnie Angie Fuertes. Yes. Ayun. Okay, nasa FB Live po. Congratulations sa ating first lucky winner na si Donnie
Finally,
Angie Fuertes. Yes. Sobrang daming pinagdaanan bago mapunta kay Donnie, partner. Ay.
Ayan, for the second lucky winner naman.
Ayan. Ready na kaya sila sa second lucky winner natin? Iroleta na natin yan. Yes. Yes, our second lucky winner is si Renz Marion F. Medice. Sana nandito si Renz Marion. Pa-comment na lang po sa FB Live or sa ating Zoom chat kung nandito po.
Ako mukhang wala ulit.
Ako, walang naggagalaw ng baso. Ayan. Nasa FB Live daw po, yata.
Ayan, I'm here.
Ayan, I'm here. Yes, congratulations, Renz Marion F. Medice. Meron kang isang set ng ating X-Structure merch na may mug, lanyard, and mousepad.
Ayan, para sa ating winners, the winners should send their full name, school, and organization sa TOPSES Facebook page to confirm and para ma-secure nyo yung prizes na nakuha nyo.
Yes. Ayan, sa mga hindi nabunot, huwag kayong panghinaan ng loob dahil meron pa tayong roleta ulit mamaya. Sana nandito na yung mga mananalo, partner, no?
Before we proceed sa ating part 2 ng continuation ng loading and analysis natin, narito muna ang presentation ng ating mga TOPSES officers para sa ating intermission number. Ayan. I-wait lang natin.
Yes.
Words I speak before you make you feel the love I lay for you will see no ending. Well, if you look into my eyes, then you should know that there's nothing here to doubt, nothing to fear. And you can lay your questions down, 'cause if you hold me, so we can fit into the night. And you know the world could die and everything be lies, still you shouldn't cry. 'Cause time may pass, but longer than it'll last, I'll be by your side, forever by your side. Take my hand and gently close your eyes so you could understand that there's no greater love tonight than what I've for you. Well, if you feel the same way for me, then let go. We can journey to a garden no one knows. Life is short, my darling, tell me that you love me, so we can fit into the night. And you know the world could die and everything be lies, still you shouldn't cry. 'Cause time may pass, but longer than it'll last, I'll be by your side, forever by your side. The world could die and everything may lie, still you shouldn't cry. 'Cause time may pass and everything won't last, I'll be by your side, forever by your side.
Ayan. And we're back, partner. Are you guys still there? Ayan. Sana nandyan pa kayo. Dahil sa first part na ating event, natutunan natin gamitin ang STAAD Pro sa pag-model ng low-rise building. Kaya ngayon naman, sa second part na ating event, matututunan natin ang continuation ng loading and analysis of low-rise building gamit pa rin ang ating STAAD Pro.
Tama ka dyan, partner. Pero bago tayo mag-proceed, i-recognize muna natin ang presence ng ating TUP faculty profs na si Engineer Edgardo Legaspi and Engineer Edmundo de la Cruz. Ayan, hello po. And also to Engineer Nick Salomon of our partner org na ingeniero.org. Hello po, enjoy po kayo sa panonood. So, huwag na nating paghintayin pa ang ating mga participants na makakuha ng more knowledge sa ating speaker. Kaya once again, let's all welcome Engineer Juan Paulo Elbersamina.
Okay, so yeah, let's resume our training. Share screen. I was told na magbasa ng question. So where's the ano? Saan ba yung mga question? Haba na. Ano bang nakatanda? Nasa taas po, sir. Ano to? Ito. I think ito. Sir, kailan gagamitin yung reference load at load cases details? Actually yan, parang recommendations po yan, no? Yung mga reference load. Um, you can still use yung other, old school way of assigning loads, no, pero I find it advantageous nung sabi ko nga sa reference load, pag nagbago ka sa reference load, automatic magbabago yung base, yung seismic weight mo, seismic mass, uh, dead load, live load, nare-reference mo kasi siya, no? So yun siya. Load cases details, of course you need the load case details to define yung mga basic loads mo, dead load, earthquake, live. Kasi you need the primary load case to generate naman the load combinations. Yan. Yung load combinations, di ba? Yung combination ng gravity load saka ng lateral load. Yan. Wala na. Yun lang naman yung mass, yung mga nakikita kong question. Bakit po dead at hindi mass yung load type? Kino-convert na po yan ni STAAD into mass. Yung ano natin, reference load na load type dead load. Yan. So, which is ito, sa seismic definition natin, may encounter. Okay, so yun nga, since I adopted the same seismic parameter sa manual namin sa structure, so I can use this. Okay, where is that? Sir, question, sa STAAD po ba limited to square column? No, hindi naman. No? In fact, ang si STAAD is a general purpose program na pwede mo siyang gamitin sa building, pwede din siya sa other type of structure, dome, pwede rin, no? Yan. So hindi namang square, no? Pwede ka ding rectangular. Okay, what else? Ito, always the case ba na restrained ang nakamodel or pwede rin na na-iso footing na agad unless may ready na other? Ayan. Difference ni floor load and area load. Honestly, ako di ko pa nagagamit yung area load. No? Floor load pa lang. Yan. Floor load lang. No? So, since hindi ko pa siya nagamit, I can't differentiate it na paano. In most building naman, no, floor load will do. Kasi sa floor load, you can customize if it's one-way loading or two-way. Yung ginawa ko, default two-way yan. Tinuway ko siya. No? So you have an option to do it one way. So halimbawa, ito, double-click ko siya. Yan. So may nakikita kayo dito, di ba? One-way distribution. So pag alam mong one-way yung slab mo, i-click mo to. Okay? I-click mo yan, tapos mapapansin mo, wala kang loading sa short direction. Mapupunta dito sa long direction. So that means nag one-way loading siya. Okay? Mayroon ako nakita. Ano po commonly used? ETAB or STAAD? Yun nga po. Si STAAD kasi is a general purpose program. So pwede mo siyang gamitin in almost all type of structure kasi. No, retaining wall, tank, underground tank. Yan. Okay. Whereas si ETABs is specific for building. No? Ang kinaganda kasi pag specific for building like ETABs, yung output niya medyo customized to building. Yun yung maganda sa kanya. Okay. And of course, yung company. Si ETABs is CSI, Computer and Structures, while si STAAD ay Bentley. Bentley po siya. And by the way, no, ang TUP po has unlimited access to Bentley software, no, for 1 year. Yan. Thanks to to the administration, yun, kina Dean, sa BPAA, no, they were able sa back, no, sila po yung nag push to purchase the ano. So generally ang pinush is the purchase of software, no. So ito ano na lang, na-narrow down na lang sa Bentley software. Nakapag-model din po ba ng arc beams? Pwede, no. If you follow yung tutorial po ni Sir JP De La Rosa, no, ano siya doon, yung beam niya doon paganyan, no. Yan. Pero ang ginawa niya is basically straight din siya pero meron kang mga mesh, no. Yan, may mesh ka. What do you call that? Parang division. Yan. Okay. Parang ang analysis niya is small straight element. Yan. Eccentric footing. Kasi po sa STAAD, we're only modeling the superstructure. No? So si footing, sa RCDC, which we will do later, isolated. No? Tapos sa SFA, STAAD Foundation Advanced, medyo advanced na yun, kaya niya yung mga ganun footing. But ang lagi kong sinasabi, no, kaya po ang approach ko sa tutorial is I do it manually muna, no? Like before kayo mag-delve into software, as much as possible gawin niyo muna sa manual calculation. Yan. May mga nagko-consult kasi sa akin dati. Phoenix niya, no? Phoenix niya yung condition. Yan. Tapos eccentric footing, lumaki, no? Remember kasi pag naka-fixed support ka, hahata ka ng moment. And from the concept ng P over A, di ba, plus 6M over BD squared, yan yung basis mo ng size ng footing. Yan. So pag may moment na na-detect sa model mo, due to the fixed support, lalapad yung footing mo. Kahit 2-story ka lang, no. So ang technique doon, no, is sabi yung question ni Sir kanina, no, kung kaya naman ng pin, you can do it pin para concentrated load lang yung matransfer such that you can just use P over A. Diba? Na-eliminate mo ito sa equation. Ano lang po yun parang technique na yun. Pag mga medyo lightly loaded structure, no? Definitely pag high rise ka na, regardless kung eccentric yan, kailangan fixed support na yan. And syempre, normally, when you're going high rise, mid rise to high rise, bumibigat na yung structure mo, hindi ka na nag-isolated Most likely, pwede ka na mag-combined footing going to mat foundation. So sa mat foundation, ano na yun, malapad na yun, no? Cover mo na yung lahat ng support nun. Okay, sige. So let's continue po sa seismic definition. Seismic definition, then add. Yan. So before that, ito yung manual natin. Although may table na kayo dyan, so sabi ko nga, inadapt ko na lang yung parameters since Manila is around 10 kilometers lang naman from fault line. So this is valid, no? NA is 1, NB is 1.2. Okay, so ito yung seismic parameters na i-input natin kay STAAD. Zone 4, importance factor ay 1. Ito yung response modification factor or ductility factor, 8.5. C sub T is 0.0731. And soil type D, and NANB 1 and 1.2. Input ko lang muna, no? Mamaya ko explain. So, UBC 97. Yan. Once nyo lang i-define to, no? And then UBC is, again, an American code. But take note, no? Heads up, sabi ni ASEP, by next year or so, magta-transition na tayo sa IBC. Because as you remember earlier or recently, nag-turn over si PVolts na mga spectral acceleration map, no, which is needed sa IBC code. Yan, or IBC type na code, seismic code. Yan. Ngayon kasi naka-zoning tayo, no? So yun. But essentially, sabi ko, yung main base shear nyo will still ganun pa rin, force equals mass times acceleration. Nagbabago lang tong parameters na i-input natin, no? Yan. So zone is 0.4, importance factor ay 1, R in two direction ay 8.5. Soil type is 4 because that corresponds to stiff soil profile. Yan. NA is 1, NB ay 1.2. Then C sub T is 0.0731. Okay? Yan. So typing job po yan. No? Okay, please type that. I'll give you 5 seconds. Okay, so once done, click add. Yan, bigla magtatanong si STAAD sa'yo, ano yung weight mo? Saan mo kunin yung weight? Yan, so remember, meron tayong reference load. So ito po yung reference load natin. Click natin yan. So ito, na-detect niya yung dalawang reference load, no? DL1 saka DL2. Yan, double click lang natin para madala sa kanan. And then click add. Yan, okay? So basically, na-define na natin yung seismic parameter plus the weight from the reference load. So okay na tayo sa seismic load. Okay, sige, save ko muna siya. Okay, and then ito yung ating, balik ako dito. Yan. So say ito yung project location natin. Hindi na tayo mag-accidental torsion because incorporate natin siya sa load cases mamaya, no? Sa mamaya po. So basically, you will see, no, almost 90% ng Philippines nasa zone 4. So parang pag magkaka-project kayo, most likely nasa zone 4 kayo. Yan, okay? So hinati yung Philippines into 2 zones. Yan. And yan, ito yung distance from the fault line. So you can find that sa faultfinder.com. So ito yung tabulation ni UBC sa Amerika. Then ito naman sa Philippines, NSCP. Mapapansin nyo, medyo malaki yung table sa UBC, no? Because malaking bansa ang Amerika, di ba? So yan, no? Kasi yung West Coast, yan, so nandyan sila LeBron, di ba? Yung mga Lakers, California. Basically, zone 4 din sila, no? While yung East Coast, most portion ng East Coast, banda dito. That means, hindi nag-go-govern sa kanilang earthquake. Ang liit nung PGA. This is PGA, Peak Ground Acceleration. So basically sa atin, ang PGA natin ay 0.4. Okay, ito po yun. So sa Palawan, zone 2, 0.2G lang. 0.4G. Ibig sabihin, multiply mo yan sa G. 9.81. 0.4 times 9.81. So almost 4 meter per second square, di ba? So parang yan yung magiging acceleration ng building mo, no? PGA. Pero maraming seminars I attended from PVOX, they said we can experience as much as 0.7 pa nga, no? Or 0.8G. So ganun kataas, no, yung acceleration natin sa design earthquake, no? Which statistically happens once every 500 years. No? Kasi 10% probability of exceedance in 50 years. Ayan, no? So therefore, kaya mapapansin niyo dito sa ilalim, no, sa UBC, mas marami siyang structure type. No, mamaya sa ano. Okay, standard occupancy tayo. So 1, yung importance factor. Yan, 1. Yan. So ito naman yung R value. Yan. So sulat ko ulit yung formula, no? V equals CVI over RTW. So na-define na natin importance factor, 1, kasi standard occupancy lang naman tayo. Hindi naman tayo hazardous facilities. By the way, nagka-project kami sa Laguna. It's just a 2-story pero essential facility siya. So na-qualify siya as hazardous facilities. So ginawa siyang 1.5. So what I'm saying is, it depends pa rin, no, na discretion pa rin yan ng owner or ng engineer to determine ano yung load, yung structure type mo. No, critical facilities, medyo tataasan mo yung importance factor. Therefore, yung base shear mo tataas by 50%. Ayan. Okay. Okay, what about CV, mamaya explain ko. So, R muna tayo. R is here. No? So, we are, ang ano natin, ang ating framing system is moment resisting frame. No, this is already a terminology, no? Moment frame. Pag sinabing moment frame, it's purely beam and column. Yan. Kasi kapag may shear wall na, dual system na yon. Meron ka ng shear wall at the same time, meron ka pang moment frame. So moment frame lang tayo. Tingnan natin, no? What if I use ordinary reinforced concrete moment frame? Say 3.5, yung R. Ano yung under zone 4, ano ang sabi ni code? NP. Di ba? Ano ibig sabihin ng NP? Not permitted. So it's not permitted. No, hindi ka pwedeng gumamit ng ordinary moment frame sa zone 4, which is about 90% ng Philippines. What if I use intermediate moment frame? 5.5. Okay? Ano sabi ni code? NP ulit. Not permitted na naman. Yan. So parang lumalabas, no? Parang by default, kung ang framing system mo is beam and column, 8.5. Kasi theoretically, NL siya. No limit, no? Sa code. Yan. Okay, so that's why it's 8.5. Okay? The reason is, no? This is the ductility factor. Ibig sabihin, among all the three framing system, dun sa tatlo, siya yung pinaka-ductile. That means, 'di ba, sa formula ng CVI over RTW, sabi ko, this is a reduced base shear. No, reduce pa 'yan, no? Ni-reduce ni code. Para maging economical yung design, no? But sabi ni code, if you use R 8.5, make sure na ang detailing mo ng bakal sa structure mo is ductile. So you will follow the seismic detailing provision ni code. Yan, para maging ductile. Okay? Sige, okay. So I'll take a look to sa formula. CVI over RTW. If I use a 3.5 R, tingnan nyo, denominator, maliit. Diba? So pag maliit ang denominator, anong mangyayari sa base shear? Lalaki. Right? So therefore, pag malaki ang base shear mo, anong mangyayari sa member mo? Medyo lalaki. Right? Nalalaki siya. No? Unlike if you use 8.5, malaki ang denominator mo, liliit yung base shear mo. So parang parang conflicting, no? Pero the reason nga is ductility. No? Kumbaga, you will use a greater base shear pero dito sa ordinary moment frame, hindi stringent ang detailing, no? It all boils down sa detailing ng bakal. Ibig sabihin, hindi ganun kasisinsen yung mga hoops, yung mga ties, reinforcement mo sa column and girder. Yan. Malaki lang yung section mo. Kaya parang ang perfect analogy ko dyan si Pacquiao. Diba? Kumbaga payat si Pacquiao, slim siya, pero yung laman niya, no, ductile. Kumbaga, kaya niyang tough siya, no? Kaya niyang ma-absorb a lot of punches. Pero meron siyang, if you compare that to an ordinary moment frame na large, na medyo malaki yung yung section, pero yung loob, which yung mga details ng bakal is hindi ganun kasisinsen and hindi siya ganun ka-ductile. Okay? So ganun po yung parang analogy doon, no? Okay, so we are now done sa R. Okay, so let's check yung CACV naman, no? Ito yung sa UBC. Yan. Ito naman sa NSCP. You notice si CACV is a function of NA. Yan. So, saan si NA? Ito naman si NA. Yan. Pag 10 kilometers under source type A, it's 1. Kaya ako dinefine kung ano yung source type nung ano natin, fault line, di ba? Kasi if you defined it as A, tapos ibangga mo sa 10 kilometer distance from the fault line, your NA is 1. Then your NV is 1.2. Okay, so pag after mo makuha si NA, NV, makukuha mo na si CA, CV. So here, so dito naman sa CACV, it's now a function of soil type. Yan. So soil type D tayo. So pero wala tayong soil report. Okay. Ganito 'yan, no. When I was a geotech, no, kami na nagbibigay po niyan. Kami na nagbibigay ng seismic parameters no. Part na siya ng scope of work niya siya. Kasi ito yung definition ng soil type. Kasi geotech ang nakakaalam ng soil type beneath your structure. Tayo sa definitions. Yan, okay? So what is this is the definition of soil types. Yan. So meron kang SA, hard rock. SB, it's rock. SC, very dense soil and soft rock. SD, stiff soil. Mapapansin nyo yung SD, yung range ng value niya is 15 to 50. Medyo malaki, no? Medyo mataas yung range. No? And in my experience as geotech, dito papasok karamihan ng soil type. No? Yung 15 blows, by the way, this is blows per 300 mm. Kumbaga yung driller mo, medyo malalaki katawan ng mga yan, magdadrop sila ng hammer, yan. So magpe-penetrate sa soil. Yan. Tapos bibilangin nila how many blows it takes to penetrate every 300 mm. Yan. So if it takes about 15 to 50, yan, medyo every no? Hanggang sa at least 10 meters no from the ground, and 10 to 15 meters minimum. Yan. So if that's your SPT value, you will qualify as ST. Okay? Higher than that, SC ka na. Medyo matigas na yung lupa mo. And if you now reach bedrock, hindi na kaya ng hammer yon ni driller. Magko-coring na siya nun. Coring na po ang tawag doon. So RQD naman yung term, no, pag rock na. Yan. So in most cases, SD po tayo. Pero yung bandang Binondo, bandang Sampaloc yata, no, Espanya, yan, malalambot po lupa dyan no. Even sa TUP, alam ko, ang lambot ng lupa dyan, no. So baka maging SCT pa. May part ng Quezon City, say bandang Novaliches, no, nakakabasa ako ng soil report dati doon, SC, no. Kasi pansinin niyo yung Novaliches is papuntang Biak na bato, di ba, ng Bulacan. So na doon, medyo rock na doon. May portion din ng Makati CBD kasi malapit na yung sa Guadalupe, no? Kasi yun, 'di ba, sa papuntang BGC, may bato na doon, no? Pwedeng mag-qualify as SC. Okay, pero yung after ng cash and carry, malambot na po lupa diyan. Okay, so yun po. Kaya nanggagaling madalas kay geotech itong parameters na to. So what else? We're done sa okay na tayo sa CV, I, R, okay na, W, okay, period. So what's the period? So tayo dito sa NFCP. Yan, ito po yung 4 formulas na sinasabi ko. And then ito naman yung period. So we have method A na ang period is C sub T H raised to 3/4. So parang basically as your height increases, your period increases. Di ba? Makes sense, no? Kasi nagiging flexible ka na habang tumataas yung building mo. So pag concrete, it's 0.0731. And pag steel, 0.0853. Makes sense, no? Mas mataas si steel, no? Kasi, di ba? Maninipis yung section ng steel, di ba? So may tendency at the same height, mas flexible si steel. And that's method A, no? Then for method B, yung theoretical, it's 2 pi. Saan na yun? Yan. Square root of m over k. Yan, 2 pi square root of m over k. So, kumbaga, nireconfigure lang ni code, no? Pero it's essentially 2 pi square root of m over k. Ibig sabihin, the period depends on the mass of the structure and the stiffness. Yan. Sige, derive natin, no? Remember, mass is equal to, or weight is equal to mass times acceleration, di ba? Or due to gravity. So therefore, m is equal to w over g. Yan. So w over g. So yun yung mass. Okay? Then ito naman, therefore itong term na to is your k. Di ba? Delta I squared over delta I. So matitira delta I over f. Delta over f. And that is your k, no? That is 1 over k kasi nasa denominator si k. Remember, ang basic natin, theory ng STAAD is analysis, matrix analysis or stiffness method na ang formula is P equals ST. Yan. Kaya ako, pag sa curriculum, pag nagtuturo ng STAAD, ini-introduce ko muna yung mga students sa stiffness method. Kasi yan yung background ng software. Lahat ng software, ETABS, STAAD, SAP 2000, yan, MIDAS, lahat yan, no? And so we can rewrite this as F is equal to delta, K delta. Yan. So the stiffness is K, the displacement is delta. So therefore, transpose ko lang to, no? 1 over K is equal to delta over F. Okay? So ito din yun. Ayan. So that's it, no? 2 pi square root of m over K. Okay, so anyway, covered na po ni STAAD yan, no? Kino-consider din po niya yan. Okay, diba? May binigay tayong masses, no? So alam niya yon. Then yung stiffness is siya na magko-compute niyan, nung stiffness ng structure mo. In matrix lahat yan. Okay? Okay, so that's it. We're done sa seismic definition. Okay? Then we can now proceed sa load cases. Yan. So typing job lang po to. Then add. Okay, so first EX. So that's seismic. And so add. Next is EZ. So seismic again. Add. DL1, ito yung self-weight. So that's dead load. Add. DL2, yung superimposed dead load. Add. LL1, that's the live load. Add. LL2, ito yung may gym. Add. And lastly, ito yung LLR, roof live load sa roof deck. Okay, and then add. Mahalaga itong loading type, no? In case na mag-auto-generate ka ng load combination, kailangan to. Okay? Pero in this training, gagamitin natin yung I had a permission kay Sir JP De La Rosa to use yung load combination natin. Okay, so lagyan ngayon natin ng laman itong mga to. Okay. So madali lang itong mga earthquake kasi na-define na natin siya dito. So EX add. Okay, so punta tayo sa, sige, by the way, I'll give you 5 seconds to type in muna itong mga to. Okay? So lagyan natin ng laman yung EX. So, punta tayo sa seismic. Yan. So, dito po natin i-define no, yung accidental torsion. So, dahil EX yan, that's earthquake along X. 1 multiplying factor, andito po yung 0.05. Yan. Di ba sabi ko kanina, no? Ayaw natin ang first mode distortion, no? But dahil symmetric yung structure natin, sabi pa rin ni code, maglagay ka pa rin ng accidental torsion. Kasi kapag symmetric ang structure mo, symmetric ang distribution ng column, mga shear wall, theoretically wala kang torsion. Kasi symmetric eh, no? So sabi ni code, maglagay ka pa rin kahit papano. So multiplying factor is 1 for natural torsion. So add. So ibig sabihin yung mga natural torsion ng building mo, no? I-consider niya. Close ko muna to, then proceed tayo sa easy. So same procedure, no? Lagyan natin ng laman, add. Seismic load ulit. Say direction, multiplying factor 0.05, multiplying torsional moment is 1. Okay, then add. Okay, close. Yan. DL1, so remember may reference load tayo, di ba? I-call lang natin yun, no? I-reference lang natin. So DL1 add. Okay, and then nasan si reference load? Wala, no? Nandito po siya, no? Sa repeat load. Yan, reference load. And then DL1. Okay, and then add. Okay, close. So same procedure, no? DL2, select, add. And then repeat load, reference load, DL2, and then add. Okay, close. Okay, so we're done. No? Pag clinic nyo yan, ito na siya. Okay, yan. Reference load. Okay, next is LL1. Then add. Okay, then floor loads. Yan, dito natin magagamit yung group na ginawa natin kanina. Okay, LL1 is 1.9 lang. Yan, then group. Yan. Remember may group tayo ng LL1, no? Okay, then hindi ko na papakialaman yung one way, no? I-default ko na lang. Okay, so in case na yung grouping nyo is nakita nyo naman one way, click nyo to as one way. Okay, then medyo matagal kasi pag i-identify pa muna yung one way tapos create another group for one way, no? Then add, close. So pag clinic ko yan, tingnan nyo. Oh, check pa siya. Top view. Okay. Bakit siya nag-ano? Bakit napasama yung ilalim? Double check ko LL2. Punta muna tayo sa LL2. Add. Floor load. Negative 4.8. Okay. Na-assign to view kanina. Okay, sige. So, group LL2. And then, add. Close. Ito tama no? Tama to. So, na-assign to view ko daw yung sa ano kanina. So, balik ako sa ano. Control G. Yan. Highlight. Oo nga. Yan. Na-assign to view nga. So, punta tayo sa top view. Ulitin ko, no? Isometric, view selected objects, top view. Yan, and then select ko to. Select ko yan. Associate. Okay, tingnan natin kung na-update siya. No? So, pansin niyo nagbago din dito. Okay, close. And then, ulitin ko to. LL1. Teka, save ko muna. Delete ko muna to. Add, close. Okay, yan, updated na. Okay. It's 7 primary load case. Yan. Kasi to fit dun sa load combinations ko na ready na. Okay. That's it. Display whole structure. Yan. Okay. LL1, LL2. And finally, LLR. Ito yung sa roof deck. Add, i-1.9 na lang natin. No? Floor load, negative 1.9. Parang yung yung ginawa ko kanina. So, i-cover ko to. This is elevation 10.5, di ba? So, 10 to 11. So, minimum ko 10, maximum ko 11. Okay, and then add. And close. Okay. So, ganun lang po, no? So, we're done sa primary load case. Okay, so save para mag-take effect. Okay, so we're now set sa load combination. Okay. I can say na yung ibibigay nating load combination is comprehensive because we will be considering both the orthogonal effect and the vertical effect of the earthquake. Yan. So, itong load combinations na na ibibigay ko is specific dun sa site, no? Because ang E sub V vertical formula is 0.5 CAID. Yan, no? And remember, ang CA natin ay 0.44. 0.44 NA yung formula, di ba? Ang NA natin is 1. So, 0.44 yung CA natin. Tapos, so, earthquake is combination of horizontal and vertical. So, andito yung niyan eh. Andito yung derivation niyan. First step. Okay, yan. This one. Medyo madami, no? Yan. So itong series 100 is for the load combination for design ng beam and column. So kung may shear wall ka, kasama, no? So first yung 1.4 dead load. Yan. So NSCP 203-1, ito yan. Yung 1.2 dead load, yan, very famous, alam na natin yan. Ito yon. This one. Pero may variation, no? Pag may L sub R ka, okay. Ito yon. 1.2D plus 1.6 live load. Then 0.5 yung LLR. Okay. Then meron din ditong 1.2D plus 1.6 LLR plus F1L. Ito nga yun. No? So what is F1? So sabi ni code, pag ang live load mo ay 4.8, your F1 is 1. No? Other than that, 0.5. If less than 4.8, so 0.5. So ito naman yun. Remember, meron tayong live load na less than 4.8, di ba? So kaya may 0.5 na factor dito. Okay? So yun yung mga gravity load. 1.2 dead load and 1.6 live load. Now for the earthquake, ito naman yung susundin nating formula. 1.2D plus E plus F1L. Yan. So, consider natin yung vertical effect and the orthogonal effect. Wherein sa orthogonal, if you apply 100% sa X, 30% naman sa Z direction. Kumbaga, kung ito yung building mo, ito yung X direction, 100%, 30% of that sa Z direction. Parang it's sort of, you're considering yung earthquake pag tumama, skewed sa principal axis. Kasi ito naman yung principal axis mo. Diba? Hindi mo naman masasabi kung ang earthquake tatama sa principal axis. Okay, so yun. The orthogonal effect covers that. Kaya medyo madami. Pansinin nyo sa load combination, 100% X, 30% sa Z, 100% sa Z, 30% sa X. And since cyclic yan, earthquake yan, plus minus. Okay? And ito yung derivation no 1.42. Yan. So 1.2D plus E plus F1L. So EX plus EV. So EX. So EV is 0.5 CAID, di ba? So 0.5 times 0.44 na CA. So 0.22. So D. Common term mo D. 1.2 plus 0.22, that is 1.42D. Okay? Tapos plus EX plus F1L. And remember, may orthogonal effect tayo, kaya nagkaroon ng 1 and 0.3. Okay? Kaya dun galing yung 0.42 na factor dito sa taas. Okay? So, 1.2 minus 0.22, so 1.12 naman. Okay? Then ito naman is from 0.9D plus E. Ito. This one. Yan pala. Diba? 0.9 plus 0.22, 1.12. Okay? So 0.9 minus 0.22, 0.68. Okay po? Yan. Kasi ito yung ating load combinations. Ito. Yan. So, ganyan kadami. No? Ganyan kadami yung gagamitin natin. So, bigyan ko lang kayo ng sample. If maglalagay ko ng specific load combination, halimbawa, click ko to, then add. Add. Ito po yung defined combinations. So, halimbawa, 501. 501. Gagawin ko, I say this is 1.2D plus 1.6 live. So, hanapin ko dito yung dead load. Say ito. Ito naman say live load. Ano yung factor niya? 1.2D. Ito naman ay 1.6. Then add. Pansinin nyo, no? Isa-isa yan. No? Isa-isa yung gagawin. Medyo tedious, no? Kung nasa actual ano talaga tayo. No? So, di-delete ko na lang siya. I'll show you a quicker way to insert that. So, using command file. So, ito yung maganda kay STAAD, no? So, this is what we call the STAAD editor dun sa mga old version. Click ko yan. Save. Sa utilities po, no? Utilities, command file. Parang this also gives me parang confidence sa software because ito yung last resort in troubleshooting the model. Pag may hindi ma-troubleshoot sa command, sa STAAD editor ka talaga magre-rely. So lahat ng ginawa natin kanina sa GUI, Graphic User Interface, dito nagre-reflect. Parang kumbaga ito yung heart and soul ng program, no? Then may algorithm na to extract those command and i-run ni STAAD. So, nandito na tayo ngayon sa load 7. So, i-insert ko na lang dyan yung load combinations. Yan. So, para mapabilis, no? Which is here. Yan, ganyan kadami, no? Control A, Control C, and then Control V. Bibigay ko naman yung file, yung STAAD file. No? So, doon na lang kunin. No? And mapapansin nyo, madami po to. It will be, medyo matagal pag-explain ko lahat. No? So we have 4 sets. No? Basically, we have 4 sets. Series, unahin natin yung series 100. Yan. Yung tinerive ko kanina. Then series 200 for drift check. Yan. Series 300 for sizing ng footing. No? And series 400 for rebar design ng footing. Remember sa footing, sa foundation, di ba? Pag nagsasize tayo ng footing, unfactored load. Ito yon, no? Yung series 300. And pag magde-design ka na ng bakal, factored load na ang i-check mo. Di ba? So, magde-design ka ng bakal, i-check mo siya sa punching, sa one-way shear check, ultimate load combination na. Pero when you check sa bearing pressure, if you will check sa P over A, di ba, plus 6M over BD squared, na formula sa SBC, i-double check mo sa SBC na dapat hindi ma-exceed yung SBC from this pressure, you will use series 300 or unfactored load. Okay? Ayan, so save ko yan and then close. Yeah, may feature to auto-generate load combos. Pero yung nga, sabi ko nga, di ba, dinerive natin, may vertical effect pa, mayroon pang orthogonal. I don't know kung kaya pa niya yun. No? Siguro if you will customize, kaya. No? So if your project is the same parameter, 10 kilometers from the fault line, ang soil type mo ay stiff soil, you can use this load combination. Yan po. So, loading, ganyan kadami yun. Okay? So, di ba? Imagine nyo, pag tinype natin yan isa-isa, baka kulang ang isang oras. Okay. So, we're done sa load combination. Then, let's proceed sa load envelopes. Load envelopes. Okay, so add. Typing job lang naman to, no? Basically, i-identify natin or i-organize natin lahat ng series 100 sa series 200, sa series 300, 400. Okay? Uy, anong nangyari? Ulitin ko. Because very important dahil later on, no, sa post-processing, marirealize nyo yung importance ng load envelopes. So, unahin ko is, I'll name that load envelope 1 na lang. No? Envelope 1. So, i-itemize ko lahat ng series 100. 1 to 6. And it's a ultimate strength load combination. Okay. Wala kasi akong drop down, so I'm using arrow key. Okay, and then add. Okay, next is load envelope 2. Ito yung pang drift check. 201 hanggang 216. Dalhin sa kanan. So this is serviceability, no? Drift is serviceability. Add. Load envelope 3 for sizing ng footing. 301 hanggang 313. Dalhin sa kanan. Serviceability. Okay, add. And finally, load envelope 4, lahat ng series 400. Okay, so this is ultimate strength. Okay, add. Okay, so pag may expand nyo na to. Okay, sige. So save ko muna siya. Save. Okay, sige. I'll give you 5 seconds. Okay. So once done, we can now analyze this. So punta tayo sa analysis. And then analysis commands. Yan. So ito naman yung default. Just click add. Close. Okay, where is the drift check? Checking drift. Yeah. Yes. Oo. Oh. Pwede to. Pwede to. Ayun nga. Provided na same tayo ng parameter. Your distance to fault line is 10 kilometers and your soil type is SD. Yung ano, pwede na eh. Yung what else? Ano nga yun? Yung sa foundation, pwede rin. Pero doon sa load series 100 yon, specific yon na dapat yun yung parameter mo. Okay, so sabi ni code, drift is a serviceability issue, no, and should be limited as much as possible. Remember, di ba? Sinasabi ko, V equals CVI over RTW. And it's a reduced base shear. Ibig sabihin, itong base shear na to, hindi yan yung actually may experience ng building mo when that earthquakes happens. Hindi po yan, no? That's why, pagdating sa computation ng drift, in-incorporate niya ulit yung R. Kasi ni-reduce niya yung base shear by R. So, para kumbaga, ito yung base shear mo, lateral force, hindi yan yung actual. So, therefore, this reduced lateral force will only get you a certain displacement na hindi yan yung actual na may experience when that earthquake happens. No? So, para maging realistic, in-incorporate ulit ni code sa formula ng drift yung R. Minagnify niya ngayon. No? Binalik niya yung R. So, mas malaki pa dyan. Okay? So, this is the maximum inelastic lateral displacement. So, dito yan eh. Medyo mabagal lang yung whiteboard ko during Zoom. Ayan po. Yan. 208.5.9.2 determination of delta M, the maximum inelastic response displacement. Okay, then sabi ni code, ibangga mo yan sa 0.025H if the period of your structure is less than 0.7 seconds. Since low rise naman to, no, definitely our period will most likely less than this, less than 0.7. Okay? Basically, ma-approximate na nga natin, di ba? T equals 0.0731 times ano yung height natin? 10.5 raised to 3/4, raised to 0.75. So what do we get there? Calculator. So I have 10.5 raised to, sorry. Hindi ko dala yung ano ko eh. Scientific calc. 0.75 times 0.07 answer times 0.0731. Ayan, I'm only getting 0.4 seconds. So roughly 0.4 seconds lang yung structure natin. Okay. Sa mga student, di ba, yun yung period is the time it takes, di ba, to return to its original position. No? When earthquake happens, di ba, mag-move yung structure mo from left to right. So the time it takes to is basically 0.4 seconds. Okay. Ayun, so saan nga? So 0.025H versus 0.7 R delta S, you will get 0.0042H. Okay? So yun yung parameters natin. Okay, so punta tayo sa load list. Okay, load list. And then, since may envelope na tayo, remember ito yung envelope for drift check, no? Series 200. Dalhin ko sa kanan. Okay. Okay. And then, punta ngayon tayo sa post-analysis commands. Dito natin i-define yung allowable drift factor natin. Post-analysis, and then define. So ito si story drift. 0.0042. Okay? Yan po siya. And then add. So i-add na rin natin si CG, center of gravity. Add center of rigidity. No? Add na rin natin. Di ba? Kasi si diaphragm command mag-output ng center of mass. So i-output naman natin si center of rigidity para ma-compare natin kung meron tayong torsion. Na-add ko na ba? Next is story stiffness. Yan. Para malaman natin kung ano yung relative differences, sino mas malakas? Si lateral X ba? Si lateral Z? Or yung rotational? Ito naman yung malalaman natin kung iikot yung building natin based sa stiffness. So add, close. Add ko na ba lahat? I think. Okay. So okay na po siya. So we can now do the final analysis. So save. And then run analysis. Yan. So wala namang error. So this is good. Yung warning, default naman yon, no? Kasi nga nakaka-detect siya ng tension compression sa model. Pero we can supersede that, no? We can avoid that, no? May titweak lang sa ano. Pero that's just a warning, so we can ignore that. And when I'm teaching STAAD, no, sabi ko nga I'm introducing stiffness method. Pansinin niyo yung process ni STAAD. 'Di ba? Ito yung formula. Force is equal to K delta, no, yung kanina. So pansinin niyo, inuuna niya yung load vector. Ito 'yon. Yung matrix nung forces mo na in-apply natin. Then kukunin niya yung stiffness matrix per each member, then to generate the structure stiffness matrix, ito 'yon. Okay? Saka niya makukuha yung delta, the displacement. Kasi ganun ang 'di ba? Ganun ang stiffness method. Displacement muna, then to get the displacement in matrix, so that's K inverse, i-inverse na yung matrix nung stiffness, then i-multiply sa force vector. So once you have the displacement vector, makukuha mo na yung mga member forces, yung axial, moment, shear, and so on and so forth. Okay, so view output file, no, to determine kung ano yung base shear natin. Okay, floor diaphragm. Yan, so ito yung floor diaphragm natin. Yan, so see? So yung center of mass daw niya is nasa 5 and 6. Ano nga ba yung model natin? This is 444, so this is 12. And ano nga yung natin? I think it's, teka lang. 333, no? 343 yata, no? So basically that's 610, no? Yan. So 10 divided by 2, 5. Yan, sa gitna. Okay? What else? So 12 divided by 2. So nasa gitna, no? 6. Okay? So nasa gitna yung center of mass natin. Okay? So makes sense, no? Next is story drift. Pasado ba tayo? Yan, pasado naman lahat. Okay, kasi low rise tayo eh. No, basically, if you are low rise, medyo stiff yung structure mo. Ibig sabihin, you are not drifting yung lateral mo. Hindi ka nagdi-drift ng masyadong malaki because stiff ka. Relatively stiff structure ka. Okay? Kasi drift is yung difference ng displacement between floors, no? Kumbaga, this is delta 1, this is delta 2. So the drift is delta 1 minus delta 2. Tapos divide mo sa height, yung floor to floor height. That's why it's called drift ratio. No? It's ratio. Unitless, di ba? This is in meter, this is in meter. So unitless yan, kaya drift ratio. Okay, so verify natin. For example, where's my 1, 2, 3, 4. Ito pala. Huwag yan. Yung sa taas tayo tumingin, sa roof. Ito. So, tingnan natin yung definition, no? Height. So, this is the third floor and the roof level. Ito yung displacement sa X, displacement sa Z. So, naka-centimeter yan. So, ito naman yung drift. Okay. So, differentiate natin yung yan. So, sabi niya, sa fifth or sa roof level, nag-drift ka ng 1.9968 sa X. So, parang ganito na lang drawing ko. So, umurong ka ng 1.9968. Centimeter yan, centimeter. Then, sa fourth, at the same location, under 201, load 201, nag-drift ka naman ng 1.4744. Yan, kunin nyo lang yung difference niyan. Sige, compute ko Okay, clear. 1.9968 minus 1.474. So, 0.5228. Or yan, ito, 0.5224. So, nakuha na ni STAAD. Tapos, divide mo sa 3 meters, yung floor to floor height. So, that's your ratio. Okay? And divide ko, no? Divide by, ang 3 meter ay 300, di ba? Okay, 0.5224 divided by 0.0017. Yan. Okay, so pasado. Okay? Kasi ang I'm getting 0.0017. So ang allowable natin, di ba, is 0.0042. Okay? So ganyan po mag-check si STAAD. Next is center of rigidity. So same location, 5 and 6. Okay? So wala tayong hindi ikot, no? That means walang torsion. Same location si center of mass and center of rigidity. Kaya in actual, kapag medyo irregular yung structure nyo, si architect, no? Yan, i-check niya yan, no? And stiffness. Okay, yan. Lateral stiffness. Pansinin natin, medyo konti lang yung difference, no? So, remember, ito yung isometric natin. Konti difference because squarish yung building natin, eh. Diba? So, ibig sabihin, si X direction, ang lateral stiffness nung first floor, pili na lang tayo ng second floor, halimbawa. 1.3. Times 10 raised to 5. Pero si Z is only 1.2. Ibig sabihin, mas malakas yung axis natin sa X direction than sa Z direction. Okay? Kasi this is 444 pala to. Yan, 444. Okay. Ito, this is 343, no? 343. Okay. Yan, so mas mahaba, no? Mas mahaba tayo sa this direction. Kaya mas siya, mas flexible. Pero very minimal lang eh. No? Kasi nga squarish tayo. Yan, 7, 7. Yan. Kung medyo rectangular yan, mapapansin nyo, mas pronounce yung difference ng lateral stiffness ng X and Z. But if you will check the rotational stiffness, pansinin niyo yung exponent niya. Times 10 raised to 7. Ito 6 lang. Okay, 6, ito 5 lang. Ito 6. So that means it's very unlikely na mag-rotate ang building mo. Kasi ang taas ng rotational stiffness niya. Okay? And it was proven, no, na dahil nga yung center of rigidity natin and center of mass is in the same location, we don't expect rotation or ano. So hindi natin ma-expect na mag-govern ang rotation as first mode sa dynamic analysis. Okay? So basically ganun po, no? Ganun yung that's how you initially check, no, kung iikot yung building mo. Okay? And last is the base shear. To check. Yeah, pag may nag-fail sa story drift, yes, so change section, medyo gagawin mo siyang stacking, medyo palalakin mo. No? Kasi nga, you're drifting because you're flexible. So you're flexible because your section is small. No? So to comply with the code, kailangan mo maging stiffer. No, kung pinag-uusapan na is high-rise, of course, yan, you will add shear wall. No? Ito po yung ating base shear. Okay. Since 12:30, no, siguro tapusin ko lang sa base shear. Then I have here spreadsheet natin dito. Gamitin ko na lang din yung kay Sir JP De La Rosa. Although I have my own base shear spreadsheet. Okay. Yan. Kasi dito sa spreadsheet is na-incorporate na niya yung mga formula sa code. So I can give this because nasa nasa channel ni Sir JP De La Rosa. Yan. So input natin yung to verify yung output ni STAAD. So ito yung in-input ko, di ba? 0.4, 1, 8.5, 1 and 1.2. Soil type is 4, 0.0731. Okay, ano yung height natin? 10.5. 10.5. Yan. So I'm getting 0.426 seconds from the method A. Ayan, ito yung CACV. Palitan ko lang yung yung height, yung weight. Yung weight dito. 4,641.36. 4,641.36. Okay. So ano yung base shear natin? 600.65. So ito, andito yung yung 4 formulas. So first, ito yung lagi ko sinusulat, CBI/W over RT. So lumalabas ang base shear niya na nakuha is 983. While the Vmax, ito naman yung sa 2.5 CAIW over R, 600.65. Sa Vmin, ito 224, and the other formula 209.68. That means ang nag-govern ay hindi ito. Hindi siya, kundi itong Vmax. See? So si Vmax po ang nag-govern. So this is another parang rule of thumb, no? If you're analyzing low rise, it's most likely na ito ang mag-govern. See? Unlike ito, this is more likely to govern in mid-rise to high-rise. No? Definitely high-rise. Mid-rise to high-rise. Kasi pansinin nyo, sa formula nito, dependent ka na sa period. No, whereas itong low-rise, itong Vmax, walang period na formula. Yan. Ibig sabihin, andito kasi yung plateau. No? Ito yung plateau ng response spectra na ginagamit natin sa code. Yan, yung 2.5 CA. Ibig sabihin, sa response spectra, na-reach mo yung parang relative period ng mga structure na sensitive sa acceleration. Yan. Ibig sabihin, ang mga low rise is more likely sensitive sa acceleration. Okay? And so, yun yung natin, maximum, no? Acceleration versus period. Response spectra is a plot of acceleration versus period. While yung mga mid-rise to high-rise, nandito sa region na to. Yan. No? On this region. Okay? So, Vmax ang nag-govern. Kaya sa mga student ko, ito kagad sinecheck ko. First, ano yung base shear? If low-rise ang pina-plates ko, pag nakita kong hindi Vmax ang nag-govern, there's something wrong. Okay? So that's it. It's already 12:35. We can discuss further mamaya after the break yung mga post-processing and then all the way to design. Okay. So may question ba before we take a break? Or can I turn over to this to Tupses?
Ayan. Thank you for that informative tutorial about the loading and analysis of low-rise building using STAAD Pro. Engineer 1, Paulo L. Bersamina. Grabe, partner. Sobrang dami nating natutunan, no? Sa 2 parts pa lang yan ang ating event.
Hindi pa kompleto yan since we still have the part 3 mamaya pagbalik natin after ng lunch break.
Yes, partner. At gusto lang natin batiin na happy birthday ang kasama natin sa TUPSES officers na si Kuya Romel Jeff Pitarge. Happy birthday po!
Happy birthday!
And yes, tsaka partner, i-remind ko lang ulit yung mga students natin na dapat masundan nila yung STAAD tutorial ni Sir para mas may chance silang manalo sa ating training voucher na sponsored ng X-Structures Engineering Consultants.
Tama. Kailangan din natin i-make sure talaga na makasunod sila para magkaroon sila ng winning chance. Sayang din kasi yung 3 training voucher natin mamaya, no? So,
Yes.
sana makahabol pa kayo at makontinue natin hanggang sa part 3.
Yes, partner. Ayan, feeling ko gutom na yung mga kasama natin dito.
Ayan.
Gutom na kaya sila,
At dahil
partner?
oras na rin ang pananghalian, no? Hello? Mukhang naglalag ata ako.
Yes, okay lang, partner. Naririnig ka
Ayan.
namin. Ayan. Okay lang.
At dahil oras na rin ang pananghalian, magkakaroon muna tayo ng lunch break and we will resume the remaining parts at exactly 1:30 p.m. mamaya, kung saan ang magiging host naman natin ay sina Miss Kimberly Abad at Mr. Christian Lawrence Andrade.
Yes, partner. And syempre, while we're having a break, gusto nating ma-enjoy ng mga participants natin ang ating event. Kaya naman, during our break, pwede kayong mag-song request by typing your comments sa ating FB Live or Zoom chat at replay natin ang inyong mga request dito sa ating live.
Yes.
Ayan, happy lunch po.
Lunch break and see you later mamayang 1:30 p.m. para sa continuation ng ating program.
Ayan, ayan. Hello. Okay, ayan, we are, and the $1,000,000 question is, are you guys still there? Naku, nagkaroon na ata ng technical problem ng aking partner. Pero yes, we are here, guys. And I'm really excited for this third part of our event. And again, good day to everyone. The name of my partner ngayon, kaso nagkaroon siya ng technical difficulties, is Kimberly Abad. And I am Christian Lawrence Andrade, your host for this afternoon webinar. We all formally welcoming you to our event, which is the Crash Course Structural Analysis and Design of Low-Rise Concrete Building using STAAD Pro. Grabe! Tanghaling tapat na, magbardagulan na tayo. By the way, happy birthday sa ating graduating committee na si Romel Japitarge. Happy birthday sa'yo. Naku, ang hindi babati sa comment section, ha? Ang hindi babati sa comment section ng happy birthday, Romel, ay babagsak ngayong SEM. Naku, minsan nagdidilang ang hello ko. Kailangan talaga mag-comment. Aantayin ko yung comment nyo. Dapat may mag-comment. Dapat check nga yan, ha? Grabe, first part and second part pa lang tayo, partner, di ba? Alam ko, nandyan ka, nakikinig ka. Busog na tayo sa information. Pero yes, ang tanong, partner, may energy pa ba tayo? Ha? May energy pa ba? Dapat more energy tayo dapat kasi more knowledge pa yung makukuha natin sa ating mga speaker mamaya.
Yan, partner, naririnig na ba ako?
Yes, mas malinaw na.
Maraming salamat, partner. Again, good day to everyone. I am Kimberly Abad.
Okay. Hello. Oh, kamusta ka naman, partner? Okay na ba? Partner,
okay na, partner? Nakikita
yeah.
mo na ba ako, partner?
Yes, okay na. Nagko-comment na ba yung mga participant natin sa live? Naku ha, kailangan may happy birthday, Romel.
Ngayon naman, sure akong busog na busog ang ating participants. Hindi lang sa lunch nila, kundi sa mga knowledge na nakukuha nila ngayong event from our speakers. Onting recap lang, sa first and second part ng ating event, natutunan natin mag-model at mag-analyze ng loadings ng low-rise building using STAAD Pro. Ngayon naman, partner, matututunan natin ang member design of low-rise building using RCDC software using MS Excel spreadsheet.
Yes, tama ka dyan, partner. Kaya wag na nating paghintayin ang ating mga participants na makakuha ng more knowledge sa ating speaker. Kaya once again, let's welcome Engineer Juan Paulo Versamina.
Okay, so good afternoon. Thank you, TUPSES. Thank you, TUPSES officers. And let's continue with our design part. Medyo uunahin ko yung yung about RCDC. Medyo bibilis ako konti kasi sanay ako na 2 days training po ito no. So, and pag may enough time remaining, we'll consider other part. Okay. Share screen. What's this? Okay, yes. Yan. So, nakikita na po yung ating model. Church. Is this yeah, recorded already. Yan. So, unahin natin yung beam design, no? Beam design. I always teach na to have a preliminary beam design. Okay? before ano sa RCDC. And remember yung tinuro ko kaninang local moment, no, dito. Yan, where's the stat? Yan. So what do we get in how do we get the bending moment? That is the oops, MZ, okay? MZ for the beam and Fy for the shear. So extract natin yung MZ and Fy ni Girder. Using this procedure, sa result setup, you will right click. This one. Yan, then post-processing, right-click, RC means right-click, then result setup, and then you will choose the load combination that is required, and then you can create, you can select the range of the members, the group of the member. Remember, nag-grouping tayo, di ba? Exterior girder ba yan? Interior girder. Pag column naman, is it exterior column, interior column? So, yun yung purpose. Okay? And by property, pwede. So, punta tayo sa post-processing. And then, beam results. Okay. And then, right-click here. Right-click, result setup. Yan. So, nagamit na nating envelope 2, di ba? Sa drift check. So, envelope 1 for design ng beam, column. And yun yung purpose ng envelope, no? Okay. So, in case wala kang envelope na create, iisa-isahin mo yan, no? Tapos, dadalhin sa kanan. Then, punta ka sa range. Yan. So, you can select by group. No? So, kung gusto mong i-design yung girder, exterior girder, so, dyan lang yon. And then, click apply. Yan. So, yung lalabas dito na forces pertains to exterior girder. Okay? Yun yung technique, no? So, by ano muna tayo? I-generalize muna natin. By property, 250 by 400, yung girder natin. Okay? Then, apply. Okay? So, ito yung mga member and forces. So, click mo yung summary. Click nyo yung summary. So, yan na po. Yeah. So, as you see, you can extract maximum Fy, max mean Fy to design the stirrups, max MZ or mean MZ to design the reinforcement. Okay? Basically, yan lang eh, no? Yan lang yung kailangan natin sa beam, no? Sa beam. So we get 78 kilonewton meter as the maximum moment under load case or load combination series 100. Okay? So 78. Okay, and then I think kinumpute ko na yan, no? Start. Share screen. Yan po. So I'm sharing my screen. Yan, no? So from the formula sa RCT, no? Sa mga nag-concrete na, M equals phi RB d squared. Yan, yan yung formula natin, no? So this is the moment, phi the strength reduction factor, R yung kukunin natin, and B and D is given, no? Yun yung cross section natin. Okay, BD squared. So my D is this. Yan. So 400 yung depth, 40 yung cover, 10 mm yung sa stirrups, and then let's assume 16 mm diameter lang, no? So ano lang naman to, no? 3-story, yan. 16 over 2, that's 342. So ang depth ko ay, effective depth is 342. So one equation, one unknown, I got 2.9639. Then the formula ng rho, 0.85 FC prime over Fy, quantity 1 minus square root of 1 minus 2R over 0.85 FC prime. Okay, by the way, ang FC prime ko ay, assume lang tayo ng 21 megapascal. Then Fy 420 megapascal. Yan. 420 ko na no para. Then yan, I got 0.0078. Basically ano yan, for sure hindi natin na-exceed yung raw max. So raw min is 1.4 over Fy lang. May isa pang formula no, hindi ko na yan. Pero madalas ito naman yung nag-govern no. 0.003. So that is still greater than the raw min. So okay. And find AS, raw BT. So 0.0078 multiplies sa 250 sa 342, you got 667 mm square. And then to find the initial, this is already the maximum, no? Maximum quantity na ng bakal sa girder mo. Kasi we got the max MZ, remember? Max or minimum MZ. So 16, ang AS over area ng 16 diameter. Okay. So 67 divided by, ang area ng 16 is 201 eh. 0.06 mm square. Diba? So I got 3.32 or roughly round up 416 diameter. Yan. Ibig sabihin, pag nag-RCDC tayo, we will expect around 4, no? Quantity of 4 na 16 diameter sa design. Okay? Sige. So, to proceed sa RCDC, click nyo tong Advanced Concrete Design. And that will lead you to the software. Click ko siya. Okay, so that will hopefully open. May times na hindi siya mag-open. One of the reasons is pag wala ka pang output. Kaya nirarun muna dapat yung STAAD file. Okay, so working naman. Okay. Make sure ACI 318, no? M, no? Make sure may M po, no? Kasi that means metric. Papansin nyo, no? Meron ding ACI 318 pero walang M. So that is English. So metric po tayo. And then project, low rise, client, TUP na lang, engineer JP Bersaminar. And then beam. So pick tayo ng ng elevation, ito na lang, second floor all the way up. Okay, then create new project. So make sure yung i-click nyo ay same sila ng framing. Pag hindi the same, mag-ano po yan, magdi-discontinuous yan. Hindi mag-run si RCDC. No. Yeah. So this is already the framing plan. Yeah, you can save this now. So pero you cannot save this until ma-save nyo yung project. Yeah. So save ko muna siya. Yun yung maganda kapag straight from STAAD nyo clinic, no? I-adapt niya yung STAAD file name. So So even yung location itong ano niya, itong file, it will be the same do sa location nung STAAD nyo. So I can now save this as a framing plan. So save ko na siya. Okay, and then seminar. Yeah. Okay, framing plan. Save. Yan. So this is already an AutoCAD file. No? AutoCAD file na po siya. I'll try to open sa AutoCAD. No? Medyo ano kasi, lakas kumain ng memory ang AutoCAD. AutoCAD. By the way, if you're a student, you can avail a at least 2-year free license AutoCAD. Basta educational purpose. Yeah, ito. AutoCAD Lite. No? Parang kailangan mo lang ipakita yung proof of enrollment sa Autodesk. Okay, while waiting, punta na tayo sa settings. Settings, this general and reinforcement. Okay. Ductile design, remember, di ba? Ang formula natin ng base shear is V equals CVI over RTW. And we use R8.5, wherein this is a special moment resisting frame. Therefore, kailangan mo sumunod kay code sa special ductile design. Okay? So, hindi po pwedeng nag 8.5 ka sa base shear pero intermediate. No, that's wrong, no? So, special. Ignore torsion. Let's set a threshold siguro mga 5 kilonewton meter, no? Symmetric naman kasi yung building natin. We don't expect torsion there, no? And pangalawa, may provision kay code na due to the slab, no, that will meron tayong tinatawag na torsional compatibility. Okay? Kasi this is a mathematical model, remember? So syempre may madedetect na MX yan. Torsional moment. And then make sure rebar diameter, no? So to do that, right click. Right click kayo, switch to rebar diameter. Yan, check ko lang si 8. Masyado maliit yan. And then to be consistent dun sa manual calculation natin, iset natin yung min max natin na 16. 16 mm sa main rebar. Okay, so concrete grade, sige, pwede na itong i-25 ko na lang, FY420. Sige, add na nga lang tayo para consistent. 21. Then click nyo to, ang add, then okay. Then mag-a-appear na siya dito sa drop down. Okay, that's it. This is already good. Then click OK. Next is settings, basic load cases. And so identify lang natin yung load type. Earthquake X, earthquake Z, dead load, live load, and then roof live. Then dalhin sa kanan. Okay, and then click OK. Yan. So tatanungin ka niya ngayon, ano yung load combination mo? So meron kasing template si RCDC. Parang kumbaga sa STAAD kanina, may auto-generate siya ng load combination. But remember, meron tayong sarili nating load combination na dinerive ko pa, yung series 100. No? So we will add from analysis. And make sure lahat lang ng series 100. Series 100. So 119, 21, 22. Yeah. So all the way down from 201, all the way down will be unselected. Okay, so baba ako. Yung technique ko dito is select mo lang yung pinakaumpisa, 201, tapos move mo yung cursor sa pinakababa. Okay? Then hold mo yung shift. No? Hold shift and then click. Yan. No? Then right click, unselect. Unselect. Okay? And then click OK. Yan. So save natin. Okay, so we're done. So we can now design. Design, auto design. Ayan, so that's it. This is our design and upon looking, no, may kita nyo, top left, top right, yan yung ano natin. Reinforcement sa support and that's 3. Yan, may nakuha siyang 5. Yan. So basically malamang yan na yung maximum. Yan, 5. So ang nakuha natin manually is 4, no? Yan. So minsan kasi may mga ano yan sa may discrepancy sa decimal, no? So at least that's very near to our manual calculation. Okay, so pwede ka nang mag-generate ng beam schedule. So punta kayo sa reports, text schedule. Of course, ang common naman na presentation natin is itong ano itong type 1. Okay, then click OK. Yan. That's it. Torsion. Gaya sinabi ko, we don't expect torsion in this case because sabi nga, because may slab tayo. No? Meron tayong in actual, you have slab. Yung stiffness niyan, that will already enough to to comply with the code, yung torsional compatibility. Yan, okay? So you will have a torsion kapag meron ka talagang lalo na yung cantilever slab. Yan, tapos nakapatong sa So that may induce torsion. Wala naman tayo pong ganun. So wala tayong in-expect na torsion. Because this is a mathematical model, line element, so may madedetect at madedetect siya. No? Lalo na pag may nakapatong ka na intermediate beam sa girder. Tapos, yung moment nun, lalo na pag hindi mo ni-release, that may cause torsion sa girder mo. Okay. Yan. So, this is already your text schedule. So, save. Beam sketch. Save. Okay, what else? Reports. Yan, design calculation. Pero before that, let's generate yung section. Elevation and section. Pili lang ako ng siguro itong B4, B5, B6, tapos click lang natin lahat. Then, okay. Kailan malalaman kung i-release? Intermediate beam. Yan. Nire-release po yun. Pero the whole frame, beam and column, hindi siya nire-release. Because yun yung nagre-resist ng ano mo earthquake mo. Di ba? So dapat ano siya, may continuity. Ang intermediate beam nire-release po. Okay, so because di ko lang nabanggit, no? Because in the interest of time, kasi ang intermediate beam is a gravity member. No? It's a gravity member, nakapatong lang siya sa girder. No? So umaasa lang siya ng rotation, therefore, moment, di ba? Stiffness method, displacement muna. So magro-rotate lang si intermediate beam, depende sa rotation ng girder. Yan. Okay, so kaya nire-release siya. Ito yung sinasabi ko. Ano? As an engineer, as an structural engineer, you should learn to determine sino ang gravity member, sino ang seismic resisting member sa structure mo. And ito yung mga gravity members. Intermediate beam, the stair, yan. Because may ano siya, ang stair is hindi naman ganun yung detailing natin ng stair, tapos manipis, no? So dinidesign lang natin siya sa gravity or say dead load, live load. The slab, no? We only design the slab as gravity load, dead load, live load. And the roof truss, because roof truss is designed naman yan sa wind loading. Unlike the seismic resisting members, girder, column, and shear wall. No? Kailangan mo siyang i-STAAD talaga, no? to determine the forces. So the gravity members, being gravity load lang sila, technically you can design them using spreadsheet alone. And ito po yung style ng mga ibang design firm, no? Lalo na pagka debt engineer ka, okay, papadesign sa'yo mga intermediate beam muna, mga stair. Kasi you can do that using just Excel. No? Kasi dead load, live load lang po siya. Pero yung mga seismic resisting members, yan, girder, column, shear wall, you really need to simulate that in STAAD. Okay? And number two, another reason, may mga specific provision sa NSCP or sa code na pertaining to seismic resisting member, no? Na hindi applicable kay gravity members. Kasi magiging stringent si code dito sa seismic resisting member. No? Because yun nga, di ba, V equals CVI over RTW. No? Ni-reduce ni code yung base shear. And we are expecting inelastic behavior ng building mo. So therefore, yung inelastic behavior na yon ang sasalo the beams and columns, the seismic resisting member. Kailangan ang detailing nila is specific na may seismic provision na not necessarily apply sa gravity members. Okay? Okay, so punta tayo sa ito nga yun, napapakita yung provision na yon. Medyo yan. So ito ay provisions for girder. Yan. So, pansinin nyo, no? Ang assumption ni code, the shear capacity ng concrete during earthquake is 0. So, wag kang aasa sa shear capacity ng concrete mo during earthquake because mag-i-inelastic behavior ka nga. So, talagang wawasakin niya yung concrete mo such that ang aasa ka na lang ng shear capacity sa ties mo, sa reinforcement. Yan. Because the earthquake-induced shear force in accordance represents 1/2 for the maximum required shear strength within L knot. Okay. Also, hoops shall be provided in the following region of frame members. Girder tayo, no? So, over a length equal to twice the member depth. Yan. So, ibig sabihin, inside the girder, meron tayong tinatawag na hinging region. Okay? So, pakita ko lang yung Yung offsetting, yeah, may mga gumagawa, no? Because yun yung advantage ni ETABS kay STAAD. Kasi kay ETABS, automatic yung offset. No? Pero old school way muna tayo, no? Center to center, ano muna tayo, modeling, no? Yes, factor of safety siya, sir. Okay, earthquake load. So ganito yung nangyayari during earthquake. So this is a plot of base shear versus the displacement. So makikita nyo sa scenario A, wala pa nagka-crack, no? Then sa scenario B, and then ito yung base shear mo. Linear pa yung progression ng lateral load mo. Then nag-crack na yung nung nag-crack na yung girder mo, so therefore, yung stiffness niyan magbabago. Di ba? Remember, V equals CVI over RTW. Yan. And if you follow the code, lalo na yung seismic detailing, which is seismic strong column, weak beam, no, mas malakas dapat si column than the beam, ang unang mag-hinging, the word hinge, no? Pag hinge means mawawalan ka ng moment capacity. So yung mga girder mo, mawawalan niya ng moment capacity. Progressive, no? Yan. Kasi weaker yung beam eh. No? Unang mag-hinging yung beam. Progressive. Okay? And then until na pag na siya, nag-hinging na lahat ng girder mo, then saka na yung column. Okay? Now, during the hinging, magbabago yung yung period mo, di ba? So, pag kasi nagbago yung K mo, di ba? Period is equal to 2 pi square root of M over K. So, pag nagbago yung K, magbabago yung period. Ang tendency ng building mo, magiging flexible. Kasi may may nag-crack. So, pag naging flexible ang period mo, tumaas ang period mo, anong mangyayari sa base shear? Liliit. Di ba? That's why yung increase nito is di ba? Maliit. No, hindi pataas. Yung slope niya is mild na, no? Hindi kagaya nito na steep until ma-reach mo yung yung plateau. Yan. So ganyan po yung progress. So may hinging na nangyayari sa girder natin. Then the column. Now, yung hinging na yon may formula. May formula siya. And this is the formula. Over a length equal to twice the member depth. So ano yung depth ng girder natin? 400. So 400 times 2, 800. Yan. Tingnan natin dito. Yan. Kaya ang detailing ng girder natin dito ay meron tayong hoops na tinatawag from left and right support, no? Left and right end at 800. So this is what we call the hoops. Kasi dito mangyayari yung hinging na tinatawag. Okay? Then ano ngayon yung spacing ng mga ties mo dyan or hoops as we call? Ito naman yon. Yan. The first hoop shall be located not more than 50 mm from the face of the supporting member. This is 2010 kaya, no? Ito yung 2015. No? Outdated na yan. So sabi niya, D over 4. Yan. So ano yung depth natin? 342, di ba? Yung na-compute natin. So 342 divided by 4. 300, 150, 75 ang so nasa range ng 75, no? Yan. What else? 6 times the diameter of the smallest bar. 6 times 16. Teka, calculator pala. That is 96. Oh yan, 96. And 150. So sino ang mag-govern? Siyempre yung pinakamasinsin. And most likely ito, D over 4, which is 70 plus. So anong ginamit ni, yan, 80. Diba? Yun yung ginamit ni RCDC. Okay? So that means this is already seismically detailed. No? Kumbaga, compliant na siya sa earthquake provision, seismic provision ni code. Okay? So I think ito yung nag-differentiate kay RCDC sa STAAD. Kasi kay STAAD makakapag-design ka, pero wala pong gantong built-in detailing. and at the same time compliant sa seismic code. Okay? So yun po. And then siguro discuss ko na rin yung other provision. Where's the naliligaw yung mga ano ko. This one. Yan. So sabi niya, at any section of a flexural member, except as provided for top as well as for bottom, shall not be less than 1.4 BD over FY. Di ba? Yung raw mean, no? 1.4 over FY. Minultiply lang natin sa BD to come up with AS. And but the raw max shall not exceed 0.025. Yan. So dapat hindi mo ma-exceed yung 0.025. Ang nakuha natin, di ba, is 0.008. Yan. So wala pang half. Also, very important, the positive moment strength at joint phase shall not be less than 1/2 the negative moment strength. Yan, ano ibig sabihin nun? 'Di ba? Ito yung ano natin, girder. And ito yung typical moment diagram, no? Due to lateral load. So, tapos if you combine that with the gravity load, you will come up with something like this. Yan. So masyadong malaki yung ano, sorry. May ganyan pa. Mamaya papakita ko. So ito yung negative moment. This is the negative moment. Eh ang bakal niya nandito. Right? Nandiyan. So sabi niya, the positive moment strength, so if this is the negative moment strength, yung ilalim is the positive moment strength. Yan. Shall be not be less than 1/2. Ibig sabihin, kung ang nakuha natin bakal dito ay 8, to comply with this provision, automatic 4 yung bakal mo dyan. Okay? So, ganun po. So, ang nakuha natin kanina is 3. So, 3 divided 2, 1.5. So, 2. Okay? So, basically, ganyan po. And I got this figure from McGregor concrete textbook. McGregor is an ACI member, committee. Siya yung nagkagawa ng code to justify that provision. Ito po. Yan. Oops. Yan. So ito yung sway, no? Sway to the right. So ito yung moment diagram, and then cyclic, since cyclic yung earthquake, so meron ka din dyan. Then ito naman yung moment diagram mo due to gravity load. So combine these two, you will come up with this. I-blow up natin yan. This is it. So mapapansin nyo, no? Ito yung negative moment, ito yung positive moment. So ang liit lang, no? And if you follow that provision, yung 0.5 of the negative moment, lumalabas may factor of safety ka pa, no? That's another factor of safety. Okay, kasi lagpas yung strength mo versus sa demand. Ito yung demand. Okay? So yeah, that's the moment diagram, envelope. And yun nga, no, if you fail to follow the seismic detailing, so we wanted to avoid failure like this. Okay. Yeah, so we're done here. 3, 5, okay. So punta tayo sa design calculation. Itong B4. Let's see kung na-consider nga niya sa formula niya, no? Sa calculation niya. So beam design calculation. Wala kasi tayong intermediate beam na nilagay, so I cannot compare. Ito po, yan, for ductility. So na-consider naman niya, 6 dB, D over 4. Okay? So kung may intermediate beam, wala ito. Hindi gagawin ni RCDC. Okay, next is bill of quantities. Ang area natin ay 12 by 120 na lang, no? Ngayon kung 120 dollars. By the way, may NSCP 2015 na, no? So ano po 'yun? Pinush nila ng X-Structures 'yun, sila Sir JP sa Bentley. Okay. Okay, then click OK. So kaya I think may peso na dapat dito. Hindi lang ako nag-upgrade because bumagal ako eh. Bumagal yung laptop na nag-upgrade ako sa RCDC 10. Yan. So kung nag-estimate kayo, you can now have a parametric costing. 212 kilogram per cubic meter. Okay. And of course, makikita nyo, concrete is 49,000 while steel is 90,000. So doble, no? So doble yung cost. And yun nga, kaya nagmamahal yung design because mas mahal yung bakal. And nagmahal yung bakal because we follow the seismic detailing for the special moment resisting frame. Okay. I remember one of my project before sa parang power plant po sa bandang Visayas, no. They failed to comply dun sa dun sa R value, no. Naging namin yung discussion, no. So syempre, lumaki yung mga section kasi yung R is ginamit nila is intermediate, which is pinakita ko 'di ba sa table, no longer allowed because kasi yung first printing ng NSCP ito inalaw no. And nung fourth printing ng 2010 biglang iniba. Yan ito po. I don't want to blame Asep, no. Pero yan dito no, parang yan naka 50 no. Sa 2015 wala na to. Not permitted na siya. So I think ito yung tinake advantage ng contractor. So it's just a single number no, or pero milyon ang katapat. Because of that, because ordinary, so nagmura yung bakal, no? Kasi hindi sila required to follow special seismic detailing. So that's one of the importance ng R value because may kaakibat na costing sa detailing. Okay, so BBS hindi ko na-generate no kasi pang contractor naman po yan. Okay, so let's proceed sa column. Column naman tayo. Okay, so kasi because we're running out of time, kasi sanay nga ako 2 days to no. So save. Yeah, then let's proceed sa column. And new. Yan. So again, ACI 318M 2014. Column and wall. Iwan ko na lang to para mabilis. Then create new project. Cancel. Yan. So this is a column location plan. So save ko muna ulit yung project. And then punta tayo sa settings. design settings. Of course, ductile design, special. Uncheck ko lang yung beam shear and optimize, no? Kasi sa optimize, pansin ko, dalawang rebar, pagkakasay niya, no? So, nagiging chop suey tuloy, no? So, of course, if in your project, you can do that, no? As your discretion. Okay, so special. Okay, and then, since ang material natin is 21 megapascal, add ko siya dito, no? 21. Okay. Yung 420, gamitin ko na lang. Click. Okay. Yan. So, 21. Gamitin ko yung, oops, ba't wala? Save ko muna. Bakit wala? Hindi ko ba na-add? Okay. Okay. Yan. Save. Yan. So, andito na siya. 21. So, pwede nyo i-copy paste yan. Control C. Yan. For cover 40. Okay. So, save ulit. And then, reinforcement. So, gaya ng ginawa natin sa beam, make sure switch to rebar diameter. Yan. Column rebar, since for 20. So, start tayo sa 16. Okay. Then, click OK. May mga student, no? Minsan nagto-12 kasi mga typical sa probinsya, 12 mm, no? By the book muna tayo. Kasi when you encounter mga large project, talagang minimum 16 mm as main rebar. Okay, so set basic load cases. So gaya ng ginawa sa girder, earthquake X, say dead load. May mga nagko-question na yung iba parang 8 earthquake direction, no. Siguro pag if your structure is too irregular, no. Pero this symmetrical, I think this is already good, no. 2 earthquake. Pangalawa sa load combination natin, meron tayong positive negative doon. Yan. So, dalhin ulit sa kanan. Okay. Then, add from analysis. Again, only series 100. Then, 201 all the way down. Unselect. Okay. Okay, so save. Okay, so we can now design. Design, auto design. Ayan, so this is our design. Uniform, no? Kasi 500 by 500 tayo, no? So 12 na 20 mm ang ginamit niya. Okay? So punta tayo so this is already parang isang detail na lang ng column pwede, no? Okay? And then reports, text schedule. Teka, may inopen kasi akong Excel. type 1, of course, ductile tayo. Yan. So, if tinatamad ako mag-manual calc, no, by the way, no, I have this spreadsheet. Okay, by the way, I got this from Sir Cañete for 2021. So, ano yung ano natin? 78, di ba? 78. Yan, para initial design ko. 16 mm. Yeah, I'm getting 3 rin, no? Yan. Kasi ano, it should be 250. Okay, alisin ko to. Yan. 400. It should be 400. 50 ko lang. Tinitweak ko lang yung section para consistent sa ano, sa RCDC. Tama. So, 4 pala. Siguro may na-miss lang ako sa calculation. 4 nga, no? Okay. Next is, ito yung detail. Punta na ngayon tayo sa detailed drawing. Kahit isang column lang, no? Kasi pare-parehas naman. Okay. Yan. So, 12, 20 diameter. And then, ito po yung ating hoop spacing. 10 at 100. By the way, to visualize yung ano niya, no? Yung kanyang elevation, reports, elevation. Pag may in-ignore kayong column sa model, hindi nyo ma-generate to. C1, say C1 na lang. Okay. Yan. So this is the elevation. Okay. I have a first column. So proceed naman tayo sa detailing requirements. Okay. So ano yung clear height natin? 3 meters. Less natin yung beam depth na 0.4, so 2.6. Yan, ano yung diameter natin? 20 mm, 12 pieces. Yan. Size 500 by 500. 10 mm. Yan. So 1.51%. So is this consistent sa design? Yeah, 1.51%. And yan na, ito na yung mga formula ng detailing requirements. Kumbaga kung kay girder, may hinging region, di ba? Kay column, meron din. So that is the L knot. So ito naman yung formula. So 1 is the member dimension, minimum member dimension, 500. Then clear span over 6, 24, 26, 26 divided by 6, that's 433 or 450. So, syempre, ang pinakamalaki, yun yung mag-govern. 500 mm. Okay? So, ibig sabihin, kaya ako generate yung elevation, magpo-provide ka ng hoops here. Yan. Okay. Nag-extend siya ng 700 because may clearance siya. No? Nag-clearance siya from the beam here. Okay? Then, so that's the L knot from our seismic detailing requirement or the hinging region ng column. Okay? So ano naman yung spacing dyan? So ito naman yung sabi ni code. Yan, the transverse reinforcement. So by the way, ang minimum natin is 300 mm. Nung first printing ng 2015. Ngayong second printing, it's now 250. Yan, 250 mm na po. Therefore, sa girder, 200 na yung minimum width. Okay? Kasi medyo maraming umaangal na architect daw. Ayan, so the transverse reinforcement, ito po yung spacing. 1/4 of the member dimension. Yun nga. So parang sa girder, no? D/4. So 1/4 of the member dimension, 6 times the diameter of the smallest bar, or may formula siya ng SNAT. Bagal kasi na ano ko, whiteboard. Anyway, andito naman yan. Yan po, no? B/4. 500 divided 4 is 125. 6 dV, 6 times 20, 120. SNAT is 100. So 100 ang nag-govern. Etong 16 dB, 48 tie diameter, yan yung mga non-seismic provision. Diba? Yan yung naaral nyo sa umpisa, sa concrete. No? Yung mga spacing ng stira, ng ties. Pero when you come to seismic provision, mas mahigpit na. Ito na po siya. Okay, so kaya ang nakuha niya dito ay 100. Okay? And then, how about this? Yung mga cross ties. So, dito naman yung provision niyan. Yan. So, ito pala yung ito pala yung sinasabi kong SNAT. And then ito yung sa cross ties of the same or smaller bar size shall be permitted subject to the limitation along the longitudinal reinforcement. So kaya nilalagyan natin ng mga ties, lahat ng mga longitudinal bar. Because yun nga, shear capacities ng concrete ay 0. Hindi kayo aasa kay concrete. And so how about the joints? No? Another magandang checking ni RCDC is the joint strength. Ito po. Pasensya na medyo hirap pa na. Yan, joints of special moment frame. And most likely, karamihan sa inyo dyan mag-fail. Lalo na pag gumamit kayo ng maliit na section. Okay? And because sabi nga natin, di ba, ang concept ni code is strong column, weak beam. Yan. So in fact, ang factor of your strength should be at least 1.2. Ito. Yan. This one, 6/5. No? The flexural strength of the column shall satisfy this equation. So yung strength ng column mo should be greater than or at least equal sa 6/5 ng strength ng lahat ng beam na nakatukod. Okay. Kaya, consider yan ni RCDC. No? Click nyo lang tong reports, joint checks. Okay, so for example, C1, okay. Yan, so pansinin nyo, no? Kinukumpute niya yung moment capacity ng beam, kinukumpute niya yung moment ng column capacity. Then, ko-compare niya. So, find the maximum sa beam, 42.56. Kay column is 596. So, tapos minultiply niya sa 1.2. No? Because 6/5. Okay, so, compliant tayo. Kaya nilakayan ko na yung column. No? Para siguradong pumasa. Okay, and also, sa joints of special moment frame, okay, ang ina-assume ni code na strength ng beam is 1.25 Fy. So pag nag-free body diagram ka sa joint, di ba? Moment is equal to AS Fy d minus A over 2, di ba? Your Fy here is not, your Fs here is not Fy. 1.25 Fy. Okay, di ba? Sabi niyo, requirements of section 421 apply to beam column joints forming part of the seismic force resisting system. Okay, the forces in the longitudinal beam at the joint face shall be determined by assuming that the stress is 1.25 Fy. Kasi nga, we are expecting inelastic, no? Inelastic behavior. So, ma-i-stretch yung bakal mo beyond the yield strength. Okay? Kaya kami, yung mga project namin sa Afghanistan before, yung construction manager sa site, sa Afghan, magsasabit yan ng mill test certificate. In fact, malamang kahit sa local, no, ginagawa din. Mill test certificate ng bakal. So, bukod sa FY, kailangan niyang ma-reach yung FY as per requirement ng design criteria ni designer, kailangan ma-reach din niya to, yung TSTY ratio na 1.25. Kasi, yun nga, because we're expecting the building to behave inelastically such that your stress will be greater than Fy and kailangan may reserve strength siya up to 1.25 of that. So that's the importance nung ratio na yun. Yan. Well, so okay, so that's it. We've already done the joint check, the detailing. Okay, na it means we were able to prove that we are seismically detailed, compliant to the code, and tingnan natin yung bill of quantities. Okay, BOQ summary. Ano nga yung sinulat ko? 12 by 10, 120. 6,000 ko lang to. Okay. Okay. Ano ba yung ginawa ko na? BOQ. Ulitin ko lang. BOQ summary. Okay. Yan. So, mahal nga, no? 252. So, doble, no? 588. Okay. Now, if you, sa mga training namin, lalo na sa mid-rise, it's very common na ito, no? Pinapakita ko to, nag-equal yung consumption ng ties sa main bar. No? Sa mga large project, no? Sa main bar. So mapapansin niyo because malaki na kasi yung lateral force, no? So mas matindi yung requirement sa ties, no? And if you attend yung mga past ASEP seminar, they are attesting to that, no? Na halos yung cost ng ties or hoops nag-equalize na sa main bar. Because yun nga, because we are assuming a strong column than weak beam. So ganun kalakas dapat yung column natin. Okay, so sa girder kanina nasa ano lang tayo, no? 200 plus, no? Sa column ngayon, no? 250. Yan, laki, no? Okay, what else? So hindi na ako mag-generate ng BPS, no? It's already 2:30. Okay, generate na lang tayo ng interaction diagram. Okay, so right-click ako halimbawa dito. Interaction surface. So yes. Yan. So this is our interaction diagram. Okay. So this is a plot of actual force versus moment. Yan. So para ma-rotate nyo yan, click nyo itong itong icon na to. Okay. Since square naman tayo, so symmetrical yan. And let's click left side view. Okay. And then to get the maximum P, this is already a ultimate or strength interaction diagram. So ito pong slide bar na to, iangat nyo lang or slide pa kanan. Yan. So that's your maximum P. Then it turns out this is 3,108 kilonewton and 147 kilonewton meter. Okay. And I have here, saan na yun? Then, ito naman yung PNM. Baba ko siya, no? Tingnan natin yung maximum moment niya. Yan. So, we have 901 kilonewton and max moment of 399 kilonewton meter. Okay. So, syempre ako, when there's no RCDC pa, no, I have this interaction diagram, 500 by 500. So 21 megapascal. 12 tayo, no? So tig-apat ba? Yeah, 20. Tapos wag niyo munang pansinin yung mga forces, no? Okay, yan. So this is my interaction diagram. So ito yung nominal. So ito yung output ni RCDC, the strength. Okay, yan yung strength. Ito yung nominal, no? So this is the maximum P. This is the P balance and M balance. Okay? So paano na nakukuha yan? No? P is ano lang yan, di ba? Nandito ba Sir Kevin? 0.85 FC prime. So sila nagtuturo nito, no? AG minus AST plus AST FY, di ba? Yan yung P nominal. Yan. Tapos may factor ka pa dito. 0.7 yata or 0.8. Then dito, applyan mo na yan ng strength reduction factor na 0.65. Okay? Kasi compression controlled tayo dyan. Okay, while here, kaya mapapansin nyo, yung difference nito is masyado manipis, no? Because ang strength reduction factor mo dyan is 0.9. Dito is 0.65. Ang laki ng reduction. Okay? Then how do we get the P balance and balance? So, nung nagturo ko sa concrete yan, pinapakuha ko pa to. At least itong dalawa. Pati ito, no? Dito kasi medyo mahirap sa pure bending kasi mag-iterate na kayo dyan. No? Na kailangan mag-zero yung P tapos get the moment. So dito, to get that, isi-set mo yung compressive, yung strain ng concrete sa 0.003. The permissible, no, strain ng concrete. Then here, sa tensile reinforcement, set mo yan sa yield strain. So kung ang FY mo ay 420, that is 0.002. Yan. So kung ang bakal natin ay tig-apat, no, each side. So 1, sabihin natin dalawa dito, 3, 4. So ito yung project ko yan dito. So makukuha ko yung FS nito. So basically FY kasi nga nag-yield. Then here, project ko to. So for sure, yung FS nito is less than FY. Kasi nga, ito yung yield strain mo. Okay. Yan. So how do we get yield strain 0.002, di ba? From the formula ng stress strain, di ba? Stress is equal to elasticity times the strain. No? Stress is the Fy, elasticity is 200 gigapascal ng steel, no? Fy 420 divided by 200 gigapascal, you will get this. Tapos Fs is equal to As, yun pala, Fs na yan, no? You'll get Fs, yan, from the strain. Tapos to get the tension, or yeah, that is As times Fs. Okay. Then, ano yan? Summation forces, no? Summation forces vertical, you will get the P balance. Summation moment, you will get the moment balance. Kaya medyo iterative yan, no? Kaya mas maganda meron kayong spreadsheet to come up with that. And let's compare, no? So this is my maximum P. I got 3,108. Okay, which is here, diba? The same. No? The same sila ni RCDC. Okay? How about my maximum moment? Bakit nawawala? Okay, yan. So I got 870, 398. Tignan natin dito. Yan. Medyo may ano lang. Yan, 300 plus. Okay, so almost 800, no? Then 390 or 380 plus. Okay, so that means this is all good. Ang ginagawa ko ngayon dyan, hindi ko lang ma-demonstrate kasi hindi naka-open yung STAAD. Dito ko i-paste yung mga forces from STAAD. Yan, yung ano, FX, yung MY, and yung MZ. Okay, yung tatlong yan. Kaya sa manual, pinakita ko to. Yan, yung sets of forces na yan. Yan. I-extra ko yan kay STAAD. Then paste dun sa interaction diagram and I can determine if pasado, strength-wise, no? Yung aking section. Okay? So hindi ito yung forces kasi niya, no? Mamaya siguro if may time. Okay, so strength-wise. Okay? So these were done sa beam and column, which is part of our seismic resisting member. And maybe we should realize that pagdating sa reinforcement, sa detailing, anong napansin nyo? It's not about forces. No? Hindi siya ano, no? Hindi siya reports, detailed drawing. Hindi siya based sa forces from STAAD. Formula based na siya, no? Code based na siya. Okay? Yun po. So I think doon nagiging conservative na rin si code because ina-assume natin or we are detailing as if lahat ng joint is naghihinging. Diba? So ganun, no? Ganun ang detailing natin. Where in reality, if you perform nonlinear analysis, progressive naman po yan. Okay? Kaya siguro yung ibang firm to value engineer their design, nagna-nonlinear analysis. Okay? Which is medyo complicated. Okay? But software can do that now. Okay? So, ano yan? Practical yon pag mga high-rise project na. Okay? So, we're done. So, we can now proceed sa... Siguro, like, can we take at least 2 to 3 minutes break, no? Medyo nabibilisan ko eh, no? Okay, sige. 2 to 3 minutes.
Hello, partner.
Yan,
Break muna tayo.
hello. Break time muna daw tayo for 3 minutes, I guess. Kasi alam ko naman masyadong marami na kayong na-absorb ngayon.
Yes, partner. Shoutout
Hello.
muna tayo dyan.
Yes. Buhay pa ba yung mga participants natin dito? Comment down below. Ang di magko-comment ako, wag nyo antay bigkasin ko pa yon. Mag-comment lahat ng participants natin kung buhay pa sila. Comment kayo sa live or dito sa Zoom chat natin.
Yes, buhay na buhay pa nga ba sila?
Ayan, buhay pa. Mukhang tatlo lang ata ang papasa, ha? Ang hindi mag-comment ako, ewan ko na lang ano mangyari sa inyo this sem.
Yan, shoutout sa inyo. Buhay na buhay pa rin at nakikinig pa rin sa ating webinar.
Still kicking pa ba?
Alive and kicking pa raw. Shoutout daw Team Otnis from Pitarge, Romel, Jeff.
Yes, hello. Hello, Romel. Happy birthday again.
Yan, comment down lang sa mga magpapa-shoutout dyan.
Comment down below yung name ng mga gusto magpa-shoutout. May nagka-comment dito, RCD all pass daw.
Ayan, shoutout po kay Jane at Ria. Happy birthday sa inyo. Grabe naman. Happy birthday!
Happy
From
birthday!
Eliza Shelo. Shoutout daw kay Chad at Jo. Sabi ni Audrey Rosel. Shoutout sa inyo dyan. Buhay na buhay pa naman kayo dyan, di ba?
Shoutout Team OFWs. Sa Facebook Live ba natin, buhay pa ba sila?
Ayan, tignan naman natin sa Facebook Live. Baka mas buhay na buhay sila doon.
Sa mga participants natin, marami ba kayong natutunan? Gusto nyo magkanungan pa tayo dito? Mamaya kayo magkakaroon tayo ng Q&A. Kaya mag-prepare na kayo ng mga pwede nyong itanong kay sir para mamaya may ready na kayong itatanong. Kasi kung hindi kayo magtatanong, ako magtatanong sa inyo. Pili kayo.
Yan, shoutout na natin sila.
So habang nag-aantay tayo sa pagbabalik ni Sir, okay, mag-shoutout muna tayo. Comment down below yung name nyo dito sa Facebook Live natin or dito sa Zoom chat natin, ha? Kahit sino pwedeng i-shoutout. Kung gusto nyo magpa-shoutout sa crush nyo, pwede naman. Matatapos na rin yung SEM, pwede na kayo umamin sa mga crush nyo.
Kamusta ka naman, partner, kayong SEM? Nag-graduate na nga ba talaga?
Saan nag-graduate na? Pinipilit gumraduate.
Good luck
Ayoko
sa
maging
thesis
residente
defense.
sa TUP, grabe naman. 7 years sa college.
Ako din, girl, ayoko na maging residente ng TU.
Oo. Yung dual citizen pa ata ako, citizen, Filipino tsaka TUP citizen. Yung mga hindi magko-comment dyan, tsaka magko-comment sa comment section natin sa live natin dito tsaka sa Zoom, ay ewan ko na magiging residente ko sa TUP.
Oo, magna 9 years ka kung ayaw mong maki-shoutout dito.
Nakumuntik na ako maging abogado sa haba talaga sa TUP.
Kala ko nga doctorate na ako, girl eh.
Kala ko din. Shoutout daw sa BSCE 3E from Maria Tracy. Hello.
Ayan, shoutout kay Sir Ronel Moreno of PSU Urdaneta from Hello.
Wow, ang tara may sound effects na tayo. Kung minsan itama rin natin yung Kadi.
Ayan, shoutout pa tayo. Shoutout sa pa-baby girls from Singapore. Grabe naman yung Singapore. All over the world naman pala itong event natin, partner.
International pala tayo. Kamusta naman yung mga participants natin ngayong semester? Buhay pa ba tayo ngayong online classes? Kinakaya pa ba? Tatapusin ba natin yung course natin o yung course natin yung tatapos sa atin? Shoutout daw from Pais, Kuwait. Sana all. Seryoso ba yan? Ikaw, partner, kamusta naman yung semester mo ngayong online classes? Kinakaya mo pa ba?
Partner, hinihintay ko na matapos ang sem nito. Gusto ko na matulog ng 1 buwan.
Wow.
Sobrang. Ayan, gusto ko na matapos
Alam
yung
ko na
plates namin, syempre.
Anong plates yun?
Secret na yun, partner. Pero, hello,
Alam ko
shoutout sa
marami-
mga kagrupo ko dyan. Thank you sa pagbuhat sa akin. Sobrang
Ako lahat ng participants na nakikinig dito, makakagraduate sila ng on time, dapat talaga. Kasi kung hindi, naku, magiging residente kayo kagaya namin. Wag naman sana. Lahat ba dito, lahat ng year, di ba, kasama dito? First year, second year, third year, fourth year, fifth year.
Yes,
Tama, di ba,
partner.
partner?
Yes, partner. Totoo yan.
Ay, naku, sa mga first year dito, wag muna kayo mag-love life. Sinasabi ko sa inyo.
Nakakasira ba yun, partner, ang love life?
Naku, hindi. Lalong-lalo ng mga internet love. Lahat ba dito naniniwala sa internet love? Ngayon kasi usong-uso nga yung pandemic, di ba? Long distance. Naku, kinakaya ba ng mga LDR dito yung long distance relationship natin? Kaya pa ba? Natapos na yung ano ba? Ano ba nauna? Natapos yung pandemic o natapos yung relasyon niyo? Sabi dito, gawa lang daw ng Illuminati yung internet love.
Gawa-gawa lang pala yun. Ayun, shoutout sa mga magde-defense bukas, sabi ng ating President Elder De Guzman. Grabe naman yun. Good luck sa mga magde-defense bukas. Sana umabot
Yes,
pa
good
kayo
luck.
next year. Sabayan niyo na kami graduate. Wag na ngayong next sem. Wag ngayong sem.
Nako, good luck sa ating mga graduating dito. O, aral talaga tayo na mabuti kapit. Lalo sa mga lower year. Dapat i-priority nyo talaga yung pag-aaral nyo. Lagi kayo mag-review, advanced study kung ayaw nyong ma-delay.
Advantage na rin naman sa online class kahit medyo nahihirapan tayo.
Saka ito yung seminar natin na to, yung webinar na to, napakalaking advantage nila nito. Kasi usually tinitake to sa higher year, di ba? Yung mga first year natin, yung mga lower year natin, na nagkaroon na sila ng idea about dito. Napakaswerte nyo, guys.
Oo, mas madadalian na sila kapag na-take na nila tong subject.
Yes, tama ka doon.
Sabi ni Alvin dyan, Buknoy is not you daw.
Yes,
Hindi
it
siya si
is.
Buknoy.
Hindi ko...
Ayan, shoutout nyo na mga jowa nyo, pa-mine-mine na lang kay
Pamay na lang.
Ichan
Napaka-HD
Lawrence.
naman ng mukhang to. Grabe.
Grabe naman, girl.
Ayan. Galaw-galaw sa mga participants natin. Marami ba kayong natutunan? Comment down below kung marami kayong natutunan. Ako, dinodog show ako dito sa comment section. Ano ba yan? Maging professional naman tayo. Wow, sa akin ang galing.
Ayan, okay na daw, partner.
Okay na, ayan na. Ako, back to programming. Good luck, guys. Listen na, listen.
Again, let's welcome Engineer Juan Paulo L. Bersamina.
Okay, so let's proceed. Let's now turn to slab design. Okay. Okay, and then file new ulit ako, no? File new. Yes. Okay, kasi nagkaroon pala ng sharing violation. So I need to save this. So na-open ko kasi yung file no. So save as ako. So that's one of the rule, no? Make sure hindi naka-open yung current file name. Kakaroon siya ng sharing violation. Bukod sa kailangan may output file. Sige, skip ko nga muna. Yan. So again, ACI 318M 2014 and choose slab. Set tayo ng ano, siguro yung nasa middle floor. 4.5, yan. Iwan ko na lang to. And then create new project. Mabilis lang naman ang slab because hindi naman siya nag-finite element analysis. Moment coefficient method lang siya. Okay, so this is it. This is already a slab layout plan, no? So na-identify niya kung two-way or one-way, no? It turns out lahat kasi two-way. Okay. So you can pwede kayong butasan tong isa, no? So syempre in actual, no? Let's say if this is the area, if this is the area ng hagdan nyo or stair, meron ka ditong small beam kahit paano, no? So then you will cut this out. Ayan. Okay. So, siguro for the purpose of demonstrating yung butas, no, i-cut out ko na lang to, no? So right click kayo dito, cut out through. Okay. Yeah. And then so na-identify din niya na kung anong panel type siya. So for example, ito. So two adjacent edges discontinuous. Kasi discontinuous ka dito, discontinuous ka dyan. Okay. So what's our SDL? 2.35. Pwede nyo i-copy paste yan. Okay. For the live load, so remember this is 1.9. Ito ay 4.8 na yan eh, no? This is also 4.8. Yeah, this one is also 4.8. The rest are 1.9. Copy ko yan. The thickness, 125 tayo, no? So, siya na magko-compute ng self-weight niyan. Okay, sige, I'll give you 5 seconds. Yeah. Sige, save ko muna ulit. And then, settings. Design parameters. So, gaya ng ginawa natin sa beam and column, make sure this is switch to rebar diameter. Yan, check ko lang si 8. Yan. Common naman yung 10 mm, no? And concrete grade 21 para consistent. Add tayo dito. Then add. And since 10 or 12 mm yung i-design natin, so that is 275 megapascal. Okay. Then click OK. Or grade 40 yan, no? So nasa drop down na sila. Yan. What else? Okay, I think that's already good. Then click OK. And save ko ulit to take effect. Yan. So we can now design this. Before that, save ko muna to. Hindi ko pala na-save yung slab plan. Save. Tapos yung AutoCAD ko nag-close eh. Okay, so while waiting, punta na tayo sa design, auto design. Okay, yes. Yan. So this is the design. No? Bilis lang po, no? Then, create tayo ng slab schedule, reports, text schedule. Do you want to group? I-no ko muna siya. Yan. So this is already a slab schedule. So save ko yan. Slab sked. See, I think I can open this now. Next is general arrangement plan. Actually, ito din yung slab plan din to eh. Yan. So imagine nung walang RCDC, ako mano-mano kong ginagawa yan. No? Mag-offset ako ng line, tapos assignan ko yan ng line type na na hidden. So medyo matagal talaga. No? With the help of RCDC, automatic na lang siya. And plus, medyo mahal din ang ang mga CAD. No? Madalas 1,000 per sheet sila. Yan. Dito, automatic, meron ka na kagad drawing. Okay, reports, in-plan detailing. Yan. So sa in-plan detailing, you have top and bottom. Yan. Okay, so lumalabas. Bottom ang nauna kasi ito yung main bar natin. No? So that means this one, ang spacing niya ay 195 center to center. So ang latag niyan will be from here hanggang dito. Yan. While this one, ganun din, 10 at 195, ang latag niya is from here hanggang dito. Okay? So that's the bottom bar. For the top bar, yan. So hindi siya hindi siya continuous talaga because yan, siya Remember parang yan eh. You can idealize if I section this, so para kang merong continuous beam, no? The beam serves as your support. Yeah. So ano ang moment diagram niyan? So if you have a uniform loaded here, the moment diagram something like, oops, tap it. Sabihin natin ganyan. Something like this. Yan. Yan. Okay? So yung negative moment mo, yung support niyan is the top bar. Itong top bar na 'yon. Okay? Then yung mga positive moment na to, ang support niyan yung bottom bar na na-generate natin kanina. Okay? So that's how you idealize that. Okay, so pwede ko na itong save. So save. Okay, let's say this is the AutoCAD file. Open na lang ako ng new. Sabihin nyo dito. New. Then, open ako ng metric. Para ang units is mm. So, nagbago na kasi ang AutoCAD 2020. Dati pag nag-I for insert ako, yun yung command to insert blocks, no? I for insert or drawing, may lalabas na dialog box eh. So wala na, ito na po yung lumalabas, black palette na. So ito siya. Click niyo lang to. Then I'll find our drawing. Wala siya dito. Ayan. So for example, the framing plan, open. Ito yung generated ni RCDC, no? So click ko lang siya. So ito yung ating framing plan from RCDC. Okay, so zoom extent, Z space E. Okay. So kung nasa office kayo, no, madalas ang paper doon, A3, yan. Kaya kabisado ko ang A3, no? REC for rectangle. Create ako ng rectangle. Shift at 420, 270. 420 by 270 yun. So maliit. So scale up nyo lang yan. SC for scale. And space. Then pick an base point. Then 1,000. Enter. So A3, ano na to? This is already an A3 paper. Oops. So that means 1:1,000 scale na yan. So, medyo kulang. So increase mo na lang ulit yung scale. So, siguro 5. Tapos M for move. Lagay ko sa gitna yung ating framing plan. Okay. Yan. So pwede nyo na i-print yan. Okay, so basically that's how you insert drawings. Okay, next is tapos na yung slab eh, no? Ganun lang yan, may details ka na. Then punta tayo sa bill of quantities. BOQ summary and 12 by 10, 120, 6,000. Okay. Yan. So, pansinin nyo, ang consumption ng slab is only 111. No? So, medyo relatively mas maliit yung consumption niya ng bakal per cubic meter. No? Si girder is 160 plus, no? Kanina. Then si column is almost 300, 250 plus or 200 plus. No? Okay. So, nakikita nyo yung hierarchy, no, ng consumption ng bakal. So, mas critical yung member, mas malaking consumption niya. Okay, then let's try to verify one of the slab. I have two-way slab here. Okay, 276, 21. M is Fy over 0.85 FC prime. Yung SDL natin, di ba, 2.35. Ito ay 1.9. Lagay ko 1.9. 125 yung thickness natin. Okay. Anong ano nito? This is 3 by 4. 3 by 4. Long direction is 4. Short is 3. Ano yung type to? Two adjacent edge, no? Discontinuous. Saan dito yun? One short and one long side continuous. Yan. Okay. Bakit error? One short and one long side continuous. Masyadong ano to. So, gamitin ko yung clear span. 4 minus 0.25. Ano yun? 3.75. And 2.75. Yan. So, I'm getting 250 ang nakuha ko, no? Ano ba yung rebar ko dito? 10 mm. So, I'm getting 250. Okay. Yan. Si RCDC is 195, no? Almost 200, okay? Saan siya possible na nagano? .75, 125. Okay. Anyway, kaya ako pinapakita to, no? Maybe some of you who have taken, halimbawa, RCD may overlook this. Ang design naman ng slab is parang girder din, no? Parang beam din, di ba? Phi equals M is phi RBD squared, no? Parang ganyan din, no? Sa girder, ang rho mean natin is, di ba, 1.4 over Fy. Okay. And mapapansin nyo, yung rho ko dito is 0.0017. It's way too lower than the rho mean, 1.4 over Fy. Ano yung ano yan? Ang Fy natin, di ba, 275? So if I substitute 275 here, I'll get 0.005, I think, 0.005. No? Pero ano yung ginamit ng aking spreadsheet? Only 0.002. Yan. Kasi nasa code yan. No? Pag non-seismic naman yung member mo, hindi kagaya ng girder, no? You can just multiply that by 4/3. Yan. Kaya nandito sa formula. Okay? Kasi kung isusundin nyo yung rho mean na 1.4 over Fy sa slab, magmamahal ang design mo. Okay? Magmamahal. No? So ito, sobrang liit, no? 0.002, which is allowed naman sa code. Okay? Yun, no? If your required rho is 0.0017, which is less than the rho mean 1.4 over Fy, you can just multiply that by 4/3. And that will be your rho. Then multiply sa BD or your thickness and width, you will get your spacing. Okay? Kasi 'di ba, once you get the R, you'll get the rho, you get the AS, 'di ba? Spacing yung formula dito, no? So therefore, spacing is equal to area bar, say 10 mm or 12 mm over AS, which is yung nakuha mo dito, dito, times the unit width, say 1,000. So that will be your spacing. Okay? So yun lang, no? To refresh sa other designer, no? Kasi ako personally hindi ko alam yan dati, no? Nung na-realize ko, oo nga, no? Mahal pala yung design ko pag if I use rho mean. Okay, 1.4 over Fy. So that's it. We're done sa slab. And what else? Hindi na ako magbi-BBS, no? Pang-contractor naman po yan, no? And we can now proceed sa column, no? Because we're nearing the end of the program. So save ko muna to. Medyo mahaba kasi yung footing, no? Dalawang load combination kasi kailangan natin doon. And so by the way, to demonstrate yung ginagawa ko sa column, say punta ako sa post processing, and yun nga, still envelope 1 range. So dito papasok yung grouping, no? If I group exterior column, yan. So ang makukuha ko lang sets of forces para lang ka exterior column. Then apply ko yan, okay. And beam results, summary, and copy ko to, no? Right click. Ito yung maganda kay STAAD, no? May pwede mo siyang directly copy paste kay Excel. Copy ko yan, punta ko dito sa spreadsheet ko. And paste ko dito. Okay, then again, based sa manual, what do we need sa column? It's Fx, yan, My, and Mz. And by now, you should realize na hindi ko kinakailangan yung Fy and Fz, right? Because again, sa detailing ng shear requirements, ang nag-govern is code base. No, yung requirement, yung stringent requirement ni code. No, halos nagiging useless yung Fy, Fz. So something like that, no? Kasi nagiging formula based na tayo. Anyway, ginagawa din naman ni RCDC yan, no? Chine-check din naman niya. Pero most of the time, code base ang nag-govern. Yes, apo. May temperature slab. Temperature bar. Okay, so yan. So again, Fx, the actual force, and then the My and Mz. And mapapansin nyo naman yung MX is very small. No? Wala kasing torsion. No? Ibig sabihin, hindi umiikot yung ano natin, yung ating column. Then delete. So kung dinelete ko yan, di-delete ko din dito. Fx hanggang Mx. Okay, then delete. So once I have this, copy this, insert ko dyan, paste values. Yan. So yun. No? So with this detail, yan yung maximum demand capacity ratio, only 0.4. Okay? So pasado siya. And nasa loob siya ng interaction diagram. So this is strength-wise. No? Again, ibang usapan yung detailing requirements ni code. No, yung joint check requirements ni code. No, this is only to check if strength-wise kaya ng column mo with the given reinforcement yung moment, yung mga forces. Okay? Ibang usapan yung detailing requirements. Okay? And as I observe, no, pag kailangan dito pa lang sa column, wag ka nang as I observe, no, wag kang papasok ng 0.9 demand capacity ratio. Usually pag dito nag-demand capacity ratio ka ng 0.9, for sure bagsak ka sa detailing. Ibig sabihin, masyado nang maliit yung section mo such that hindi yung nasasagad na yung moment capacity niya. So what more pagdating sa detailing requirements? Okay. Okay, so with that, we can now proceed sa foundation. So new ulit. Yan, footing, ACI 318M. Iwan ko to. And then create. Okay. And then settings, general. Check ko to buoyancy, sliding, overturning. Set natin SBC as 100 lang. 100 na lang natin. Ano yung ginamit ko sa manual? $100 nga. Okay, concrete grade to be consistent, 21. Okay. Yan. Clear cover dahil nasa ground na yan, so 75. SBC increase, so nasa code po to, you are allowed to increase by 33% kapag mayroong earthquake or wind load combination. What else? So soil density, founding depth, bigay ko lang muna 1.5. Water table, medyo taasan ko po, no? Kasi gagawin ni dyan, RCDC, babawasan yung SPC eh. Pag nakadetect siya ng mababaw na water table. Remember yung sa Tersagi, di ba, mga bearing capacity formula. What else? Okay na. Then click OK. And then settings ulit, reinforcement. So similar to what we did, switch to rebar diameter. Masyado maliit yung 8, uncheck ko yan. And iset ko yung minimum siguro na 16 na, no? Kasi foundation naman yan. And I'm using for 420 megapascal. So So kung yung iba dyan, no, kung yung ibang student, no, nagpipilit minsan 275 eh, no? So, ano na lang yun as your discretion. So by the ano tayo, I'm used to large projects, so that's ano 16 mm at least. And then okay. Then settings ulit, basic load cases, and earthquake X, earthquake Z, dead load, live load, then dalhin sa kanan. Okay. Yan, no? So mapapansin nyo, dalawa ang hinihinging load combination. So far, ang nagagamit natin is series 100 or envelope 1 saka envelope 2. Ang hindi pa natin nagagamit is 3 and 4. So dito na natin siya magagamit. Okay, so sa design, it's envelope 4 or series 400. So add from analysis. So ang may check lang dapat ay series 400. Okay, so select here, unselect. Then check ko to. Yan. For the sizing, that's series 300. So add from analysis ulit. Okay, 101 to make sure na 300 lang ang may check. Yan. Okay, right click, unselect. And dito, minsan may naliligaw. Ayan. So right click, unselect. So make sure series 300 lang ang may check. Okay, then click OK. Okay, then save. Baka mag-crash, no? Okay, so that's it. We can now design. Design, auto design. Yan. So tama, no? Isolated footing kaya, no? So wala nag-overlap na foundation. Kasi pag may nag-overlap, mapipilitan ka mag-combined footing, no? Yan. Okay. And let's mag-section tayo ng isang typical. Say itong C14, reports, detailed drawing, FC14, okay. So, yeah. First step. Hindi ko yata na-check yung Sorry. Yung plan section, no? Hindi ko na-check. Hindi ko na-check yung top bar, no? I-unlock ko lang, no? Because naka-default yung top still, eh, no? Mapapansin nyo, no? You have the option to uncheck that. Pag isolated footing naman, no? Pwedeng wala kang top bar. Okay, then click OK. And mapapansin nyo, dependent siya sa depth ng soil. Ibig sabihin, consider nyo yung top bar pag masyado na malaki yung lupa dito. Because that will induce moment, no? Na kailangan mo tuloy mabakalan, no? So uncheck muna natin yan, then okay. So parang ang design niya is straight from the STAAD forces. So design, auto design. Yan, and then section tayo. Detailed drawing, C14, and make sure naka-check to, then okay. Yan. So ang size niya ay 2.2 by 2.2. Square footing ng spacing ay 16 at 275, 16 at 300. Okay? So that's it. Now we're done sa foundation. let's check, no? Let's just verify that si FC14 is nandito, no? Right? So pangalawa. Here. So anong node number niya? Shift N, node 15. So dito natin magagamit yan, no? Punta tayo sa reactions. And then right click ako, result setup. Yung pinakita ko kanina na technique, no? And then range, that is node 15. Actually, you can check na yung corner footing dito if you wanted to design. So to be consistent, yung muna pala. Node 15. Yan yung node, no? Yung corresponding to FC14. Then loads, unahin natin si envelope 3, no, for the sizing. Okay, then apply. Yan, so nagbago na to. And close, okay ko to. Para hindi cluttered, no? Punta ako sa annotate, remove all. Yan, so this is node 15. Punta ka sa summary. Okay, and then copy din natin to parang sa column. Punta ako sa spreadsheet. Here, then paste. Okay, so based sa manual, anong kailangan ko for the footing? That is yan. So sa beam, we get MZ and FY. For column, FX, MY, MZ. For footing, you will get FY and MX, MZ. Itong FX, FZ, shear naman yan. So, which is hindi na kailangan. No? So, FY, MX, MZ. Okay? Because the reaction is relative to the global axis. Yan. No? Because FY, because this is Y, this is X, this is Z. While yung column and beam is relative, no, yung forces na kinukuha natin is relative to the local axis. No? So, yun yung distinction, no? Yan. So, FY, MX, MZ. Okay, highlight ko yan. MX, MZ. Okay, so didelete ko to. Papansin nyo yung FY, yung MY ang liit, no? Delete that. Ito lang yung mga shear or horizontal reaction. And then delete ko din itong FX. And then FY and FZ. And also MY. Okay, so copy ko to. Punta ako dito. Ay, sorry. Alt-ESV, base values. Then next is ultimate load. No? Right-click, result setup. This time, envelope 4. Range still, node 15. Apply, okay. Same procedure, copy. Then paste. And then, delete ko to. Delete si FZ. Pati si MY. MY. Let's copy this. And paste here. Yan. So ano yung nakuha natin kay RCDC? 2.2 square. Yan. Tignan natin, no? 2.2 by 2.2. And dahil ang bearing capacity natin ay 100, increased by 33%, 133. Column dimension, 0.5. And what else? Concrete is 21. Rebar for 20. Anong ginamit niya? 16? Okay, anong thickness niya? 300. Okay, 0.3. And so, nasa verge na ng ano, no? Almost 1 na, no? Yan, okay. Depth to top. Okay, yan. So, siguro, kahit lakihan ko lang ng konti ito, 2.25 or 2.3. Papasa agad, no? Okay. And ano naging spacing niya ng bakal? 16 siya, no? 16 at yeah, so I'm getting the same, no? 270, 260. Okay? 275, no? Minimum to, no? 300 and 275. Okay? So that's it. My point is, that's why I'm demonstrating this spreadsheet, because it means you can manually do the design yourself, no? Kung may spreadsheet ka, then you can check the software. Okay? Ibig sabihin, with that approach, uh, you can you cannot rely heavily on software. So at least with this kasi pag spreadsheet, alam mo i-tweak, no? Matitweak mo agad yung parameters. Whereas by relying solely kay software, mahihirapan ka. Okay? So I think that's it. We're done from beam, column, slab. We were able to verify the design. Okay? So yan yung lagi ko sinasabi po sa mga students, no? At least you should have a way to verify the software design, no? Because garbage in, garbage out. Yan. Okay, so we're done. I think we can now entertain po questions.
Ayan, thank you Engineer Juan Paulo L. Bersamina for that instructional discussion about the member design of low-rise building using RCDC software and MS Excel spreadsheet.
Ayan.
Nati-disconnect. Zoom meeting is not responding.